Hello and welcome to our Spring Specialization suite of courses. This specialization has 4 courses: Spring Ecosystem and Core, Spring MVC, Spring Boot and REST Controllers, Spring Data Repositories, and Spring Cloud Overview. In the Spring Ecosystem and Core course, we will identify what the Spring Framework is, the key principles of inversion of control and dependency injection. We will talk about what the application context is and the different types of injections such as setter and constructor injection to wire up our Spring managed beans. This part of the course will utilize XML as a means of defining what beans are injected into what, after which we will move on to using different types of metadata for Spring dependency injection, annotations, and then Java configuration classes. We will also look at how we can use expressions, both expression language or EL and Spring expression language or SPEL, to make our configurations more dynamic. And then we will also talk about conditionals in configuration, what Spring managed beans to include or exclude in a configuration, depending on whether you're in a certain environment or whether you're just testing an application. The Spring MVC, Spring Boot and REST Controllers course will talk about how we define REST controllers utilizing the Spring Model View Controller framework in a Spring Boot application. We will talk about how we can configure these Spring Boot applications using various techniques of externalizations such as properties files and YAML files. We will define RESTful web services that can receive request parameters, or we can post or push data to those RESTful web services using HTTP. We shall also talk about how our RESTful web services can undergo content negotiation. That is, the client is asking for a response in a specific metadata type, such as JSON or XML. Can we provide the response in that format? We will then create Java clients to call our RESTful web services using REST template and its extensive API. And then finally, we will talk about how we can create controllers which will utilize the Spring Boot architecture to render web pages or views. The Spring Data Repositories course will talk about how we can integrate Java Persistence Architecture or JPI with Spring in order to access databases. We will then simplify our interactions by using the abstraction called Spring Data Repositories. We will then talk about aspect-oriented programming, where we could do logging, security, transaction management, and indeed after that we will look at transaction management in Spring applications. In the Spring Cloud Overview course, we will talk about how Spring Boot is being used extensively for microservice development. So we will look at the principles and patterns associated with microservice architectures. We will talk about service registries and service registration. We will talk about how services discover other services utilizing service registries and how they will interact with them in a client-side load balancing manner to maximize availability of services. We shall also talk about circuit breakers. Basically, this is when services fail. What do you want to do? Is there some sort of default fallback method that you want to invoke? And then finally, we will talk about the different types of client services with the various projects associated with Spring Cloud. We often refer to these as gateways, and how gateways can be used to filter requests or responses that are going into and out of our microservice architectures.
Hello, welcome to our Spring Ecosystem course. I'm your instructor, Derek Parsons. Looks like I'm having a very cool drink up there in the hot mountains. This course is actually divided up into 3 modules with 1 or more lessons in each module. Module 1 will talk about what the Spring Framework is. We'll talk about the key concepts of inversion of control and dependency injection. We'll discuss what the application context is, and then we'll go through some examples of setter injection and constructor injection. This module will be based on metadata for configuring Spring of the type XML. In Module 2, we move on to different metadata for configuration, namely annotations and Java configuration classes with what they call Bean Factory methods. Module 3 will look at ways in which we can make the configurations of our Spring applications more dynamic with expression languages such as expression language for literal replacement and Spring expression language or SPEL, where we have the capability of expressions invoking methods on Spring managed beans. We'll also look at conditionals in our configuration. By that we mean a bean will be in our Spring application based off some criteria and excluded in other situations based off some criteria.
Welcome to Lesson 1, where we'll discuss what is Spring. We'll explain the Spring Framework, what it is and why we use it, understand the role of the major modules that make up Spring, introduce key concepts such as inversion of control and dependency injection, and explain what this framework does, called Spring for you, the programmer. So a framework then, that's basically a bunch of Java classes that we can utilize to wire up or create the plumbing for our applications. So it focuses very much on the plumbing of enterprise applications so you can focus on your business application logic itself. It's lightweight, based off plain old Java objects, and it will address every tier in a traditional web application. For example, presentation layer, there's Spring MVC, Model View Controller Framework, similar to Struts, that was an older framework but far more powerful and will take care of pages and controllers and delegation down to the next layer, which is the business layer. This is where you do your business logic. It weaves together various classes that make up the plumbing for this part of your application, utilizing a lightweight inversion of control or IOC container. It will also include aspect-oriented programming or AOP support, which will support transactional management or security, for example. And then this might delegate down to a persistence layer where you have various template classes for popular object relational mapping frameworks such as Hibernate and Java Database Connectivity or JDBC. So you can use that to interact with your database. It doesn't replace it, it manages those existing frameworks. It's complementary, manages the implementations, as I've said, of these subsystems through a core distribution of classes and various configuration files to make your life easy. So for example, you won't have to worry about the remoting in RESTful web services. It will take care of that for you. You just need to create the services. Persistence, you need to create the various template classes maybe to talk to the database, but it'll take care of the database connection for you. And then finally, security, it will take care of the intricacies of Java security for you. You just have to tell it when you want to use it and how you want to use it. Its advantages. It's the most popular application development framework out there for Java. It's open source, it's modular, it'll make use of existing technologies, as I've said, persistence frameworks, logging, web service frameworks. Advantages. Advantages. It's the most popular application development framework for enterprise Java. It's free because it's open source. It's modular. It makes use, as I've said, of existing technologies such as persistence frameworks, logging frameworks, web service frameworks, and it has a testing framework of its own to make it testable. So we will use JUnit, for example. It easily integrates with that. More advantages. Promotes decoupling and reusability. What does that mean? It means that if you're decoupled from each other, you have the opportunity for reusability throughout your application. For example, class A might be talking to class B, but basically it'll take any instance of class B or a subclass of class B. By introducing a new subclass of class B and giving it to class A, you may have different behavior. As I mentioned before, it focuses on the plumbing, while you can focus on business logic. It removes common issues, courtesy of the framework, such as leaking connections. It has built-in aspects for declarative transaction management, and it's basically built on design patterns that are proven solutions that work. So Spring then, it's both a container and a framework. The container creates Spring managed objects, makes them available to your application. It's configured maybe using XML or other types of metadata to define the components that live in the container. It provides an infrastructure of classes that makes it easier to accomplish tasks. For example, templates provide abstractions that enable you not to get bogged down in the details for data access or remote calling. The framework will provide the specific instances for your classes. How does it do that? Java objects collaborate with each other within an application. They delegate from each other. We say we like to code to the interface. So again, if class A is talking to class B and class B is an interface, the container will create an implementation of class B, the interface, the actual implementation, but our code will not be aware of what that implementation is because our code is saying, I will take anything that is an implementation of interface B. So we don't need to create our object implementations in our code as we're doing here, where interface type and object equals new interface impl. Spring will create the impl and assign it to the interface type and object, in our case, in our code through configuration. Inversion of control, the building blocks. The basic concept of inversion of control is that a programmer doesn't need to create their objects, but instead they need to describe how they should be created through various rules. These rules could be configuration classes, factory classes, or other metadata configuration mechanisms such as annotation. So subsequently, your application code does not directly connect your implementation components together, but instead uses abstractions. Interface A equals an instance of interface B. Interface A, the implementation is created by Spring, and interface B, the implementation is created by Spring. It's created through a configuration that points it to the actual implementation classes themselves. Dependency injection is a pattern used to create instances of objects that have delegation patterns to other objects. However, at compile time, the calling class has no knowledge of the dependency class implementation it will delegate to at runtime, because our delegator class code is coded to the interface abstraction of the delegating class. Again, interface A needs to be an instance of an implementation of interface A, and in addition, it may have a property of interface type B. It needs to have injected into it, probably through a setter or a constructor method in the class, of the implementation class of that interface that defines that property. Spring is actually divided up into a series of modules. We've got them listed here. They're grouped together into test, core container, aspect-oriented programming, aspects, instrumentation, data access, and the web. The groups each have one or many modules. So for example, data access and integration has a module for JDBC, for object relational mapping, for Java messaging system, transactions, etc. The Spring container contains core beans, context for remoting, and maybe transaction management, and also expression language, and that's the area in which we will concentrate in this lesson. So what do these modules do? Core and beans, the IOC and dependency injection core modules for building up your object graphs through configurations. Context, Enterprise Java Beans, JMS, internationalization. Expression language, you might have seen expression language in Java server pages. It's kind of like that. It can set and get values and even execute methods. There is a Spring expression language called Spell that's far more powerful than ordinary EL you might have seen in a JSP. Aspect-oriented programming, aspects and instrumentation. The aspect-oriented programming module includes support for advices, point cuts, and you would use those behind the scenes for transaction management and for security and for logging. There is also a module for integration with another framework called Aspect-J. Spring actually leverages Aspect-J as part of its AOP implementation. Data access and integration, basically making your life easy to talk to a database. And then finally, web. There's various modules that make up this group. They're there to support the creation of web applications and RESTful and even SOAP web services. So Spring is like a huge factory that creates implementations of classes. We call them beans. It's going to utilize a configuration using metadata, XML annotations, or even Java factory classes. That's fed into the factory. That factory is called an application context. The application context reads the metadata and creates an object version of that metadata. We call that bean definitions. Each bean definition has a primary identifier. From those bean definitions, instances of what the implementation class is that bean definition represents is created. When a request is made for a bean, it uses the bean definition primary identifier, or an alias as we call it, an alternative ID. A bean definition could have many identifiers, we call them aliases. It picks it up from the bean definition and says, can you give me the bean whose ID is 1, 2, 3 or something? And it says, oh, I've already created the class implementation for this bean definition. I'll go and get it from you from the application context or cache, and I will return it to you. And by the way, it has dependencies on these other classes, so I'll pick those up for you as well. Make sure they're all injected into the class that you've created so you have a complete object graph that comes back. So Spring wires up beans. The plumbing is done for you, the wiring up through dependency injection. Without Spring, you assemble everything yourself in code. With Spring, it assembles it for you and gives you a ready-to-use object graph. So you can use it in your application straight away, and if the class you've asked for delegates down to some of its properties or other classes, Spring has already created and injected them into the class that you're dealing with. Lesson 2, the application context. Here we will explain Spring inversion of control and how it manages your Spring beans. Explain what is an application context and how do we create one. Get a bean out of the application context. In the Java application, different objects collaborate. They accomplish a single goal through various collaborations. So consequently, an object has dependencies. Such direct coded dependencies couple objects to each other directly. What we mean by that is if you create everything in your code, implementation type A knows in the code that it has an implementation type B dependency because that's also in your code. So if ever we needed to change implementation type B to another implementation type, we would have to change the code, whereas Spring will change configuration. We'll attempt to explain how Spring can help us avoid such brittle dependencies. We have a little simplistic example. We will go through this in the next lesson. It consists of a service delegating to a data access object. We will start with two interfaces, employee service and employee DAO. Now for our implementation class. It's very simple. We can see there is a dependency between the service impl and the DAO impl, and I know it's DAO impl because the dependency is in the code. It's not another type of DAO, it's definitely DAO impl. Our problem is tight coupling in the getDAO method. Our service implementation is directly tied to another implementation class. The dependency is in the code, and a code change will be required if another employee DAO implementation class is required later to accommodate a requirement change. Let's try decoupling. This is a step in the right direction. Our getDAO method now delegates to an employee DAO factory, which has a method getInstance, which because of the return type of getDAO, it was going to return some implementation of employee DAO interface. This is better. However, the client still has to look up their own dependency object itself from the factory. What happens if we use a different factory? What happens if we change the implementation of the getInstance method in employee DAO factory? It means we will have to recompile again. Can someone else do the heavy lifting? Now, this white code is looking pretty good. It's the service impl and it has a dependency on employee DAO, an interface. It has a setter and a getter for it. Nowhere is there a mention of an implementation class as a dependency, i.e. an implementation of employee DAO. Now, the problem with this is that a poor old client has to create the service impl, has to create the employee DAO impl, execute the setter, and then of course execute getDAO. It means the client has intimate knowledge of the dependencies of employee service impl. So this really won't do. What can we do then? Let's pass this over to Spring. Let it do the heavy lifting. What Spring is going to do, it's going to wire up the dependencies in some sort of configuration and not in the code. This is the basis of Spring's inversion of control. Define the rules of engagement, the dependencies in configuration, not in code, and then use dependency injection to wire up the object graph to inject a dependency into a Spring managed bean and then give the Spring managed bean back to a calling client who can easily execute a method that involves delegation without a null pointer exception because Spring has wired up the beans. So Spring operates as a huge factory. It looks up dependencies of a target class that it's instantiating. It creates instances of dependencies themselves, and it identifies those dependencies using something called reflection. So somewhere in our configuration, we say, hey, there's a method set foo. Oh, you need to go and look for a dependency that we can execute that setter and inject in a dependency. And we're going to see the configurations that do that. So the rules of engagement are not in the code. They're not in some master client class. They're just in configuration. Much as we saw with the code we started off with on the previous slide, we have a dependency that's just of an interface type in our service impl. We want to keep it that way and let Spring decide what to inject in. Let's see how this works. So, first thing first, we have a couple of key interfaces. Bean Factory is the first one. There are various implementations of this interface, And those implementations will provide methods for getting beans by an identifier. That's actually the bean definition identifier that then goes and looks at the cache of the IOC container to say, hey, I've got a request for bean number foo bar foo. Is there a bean whose primary identifier is foo bar foo? Yes, it's this one. It's the employee service impl. Okay, great. Let's return that to the client. That get bean method returns objects, so we have an overloaded method that has a second argument of the type of interface class, it's called here, that you want to cast it to. Does it contain a bean with this identifier? Does it get aliases? Talked about that before. A bean can have more than one identifier. We call it an alias. You can look it up by its alias as well. Another identifier on the bean definition. The application context is a sub-interface of Bean Factory. It provides more functionality, aspect-oriented programming, resource internationalization, event propagation, the idea of hierarchical contexts, and things to do with web application development. So Bean Factory provides the core application context adds more enterprise-specific functionality.
All right, in this lab that I'm going to walk you through, we're going to do some environment setup, and we're actually going to do our first lab where we're going to retrieve a bean out of the Spring application context. So when you open up Eclipse, you'll see something like this. The first thing we have to do is to set up what we call a settings file for Maven. This controls how we pull down our dependencies for our project on our build path. And we actually have that in this directory here under settings from your desktop. So we'll go and get that. Window preferences, Maven, user settings, hit browse, go to desktop, settings, settings XML, hit open, it's there now, and hit apply. The next thing we want to do is to open our project that we're going to work in. So file, open projects, and all our projects are in this student work directory down here. In fact, if I open up student work, there's a setup subdirectory and a solutions directory which has the solutions for all the labs, which you can always refer to. So let's go and grab that first project. File, open projects and file system, hit the directory to import the source, go to desktop, student work, setup, select my project. I can see it's there. Eclipse is going to view it. And we got some activity going down here. It's bringing it into Eclipse. If I close the Welcome tab, I'm in the JE perspective. I can see my project is there. It's got some red marks next to it, some problems it says here. That's because behind the scenes Eclipse is building this project. Let's open it up and see what the structure of the project is while it's being built for us by Maven. So we have the POM XML, which will be where we've defined the various dependencies for this project. It's actually a Spring Boot project, which we'll use in later labs. It has a resources subfolder, which is where we have our beans XML. And it has a source folder where we have our source. So our problem domain is actually a service object, which in time will delegate down to a data access object. And it has one JUnit, student service test. Still got some activity, but looks like those red marks have gone away. Our objective is to get student service impl out of the application context. So we need to configure an application context with some metadata. In this lab, that metadata is going to take the form of XML configuration. So I'm going to click on the XML file. I'll go into the source and I'll define one bean definition with a primary identifier of student service and a fully qualified class name of com student service and the implementation type itself of student service impl. Make sure I close that tag off. There's content assist in this XML editor in Eclipse, so that might be able to help you out. Make sure I save it. So what's the next thing we have to do? Well, if I go to the test class, you have to implement a couple of things there. So I've put these in myself already to save some time from typing. So here I'm defining a class path XML application context, giving it the beans XML. Up here is the reference type that can be used. I can actually take that away and just use the interface type. If I do right click, source, organize imports, it's going to say, hey, what's this application context thing? Well, I'm going to say, well, it's what I want. So now I've got the interface type. Let's clear it up a bit. Down here, I'm getting a bean. That method returns an object. I'm using the primary identifier. Instead of bringing back object, I'm saying cast it to the interface type that the implementation class implements. So let's go and check, make sure that's the case. Yes, it implements that interface. And I've done a simple assert not null, making sure the service has been retrieved. So I'll right click on the class and I'll run my JUnit. Oh, looks like it's prompting me to say you didn't save something, so I've saved something. It's found the XML according to the logs. It's loaded and we have successfully got a bean out of the application context. The JUnit is green. The key thing here is there's no mention in the client class, which is a JUnit in this case, what the implementation class is. We only have an interface type. So if I did go in here and change this to another class that implemented the same interface but had different functionality, I could just rerun the JUnit and it will pick up that new implementation behind the scenes because we're using inversion of control. We're just using the interface types here.
Lesson 4, Annotations. Here we will learn about dependency injection using a different type of metadata, Spring annotations. We'll use these annotations to wire up dependencies in our Spring Managed Beans. We will then move on to JavaX annotations courtesy of JSRs 250 and 330 to wire up our dependencies in our Spring Managed Bean object graphs. Spring Beans have an extensive lifecycle. Constructor injection occurs prior to setter injection. If our Spring Managed Bean implements the interface initializing bean, we also have an initializer method that will trigger after setter injection. One thing we haven't talked about, though, is which beans get created before other beans. The IOC container creates these bean instances and controls subsequent dependency injection on those beans. We can trace the order in which this inflation of beans is carried out by creating a class that implements bean post processor. It will implement two methods, before and after initialization. These two methods straddle the initializer method I mentioned before, and their arguments are the bean object themselves and the primary identifier that you see coming into each of the methods. This should trace the order through which we instantiate our beans. Now, what are these bean post processors really used for? To explain this, we are going to create our own custom annotation. I've called it myAnno. It's going to be around in the bytecode versus if it's retention annotation. And this annotation can only be placed above methods. And you see it above my set down method that you have at the base of your slide. Now here is my bean post processor again. After initialization is there, before initialization there, and I've actually implemented another key interface in Spring, application context aware. This enables me to inject in the application context as you see at the base of the slide and keep hold of it as a member variable. Subsequently, when I complete the implementation of after initialization, I use a lot of verbose code you see here, which is basically reflection. When an object comes in and its primary identifier, I can get its declared methods using reflection. I can iterate over those methods. I can see if any of those methods are annotated with the myAnno annotation class. If they are, I can get an array of their parameter types. In this case, I get the first parameter, a shortcut for the simplicity of the example, and I go back to the context because I'm application context aware, bring back the bean associated with the same type that I asked for. So if I ask for an employee DAO type, it will look in the context for anything that implements the interface employee DAO. It will bring that manage bean object back. I then use reflection to invoke the method that I'm iterating on the object that was passed in with the argument I retrieved from the application context. So I'm effectively executing the setter with whatever I got back from the application context via the getBean method. This means that when the object came in, if one of its methods was annotated with the annotation, a setter has been executed and a dependency has been injected into the object before it leaves the bean post processor and gets lodged in the application context. We've achieved dependency injection as an alternative to XML metadata configuration. We don't have to create our own bean post processors. Spring has built-in processors that look for specific provided annotations. Instead of using an XML configuration, the developer has moved the configuration in situ with the component class, courtesy of a suite of provided annotations. Registering the bean post processor implementations, they use reflection on every bean that is inflated by the IOC container to scrutinize its metadata, such as properties and methods for a particular presence of a particular annotation. If they are present, they secure the application context in order to retrieve a Spring managed dependency and inject it into the bean post processor. All you have to do is to register the bean post processors for each of the annotations. What you've got here in your XML is the context namespace, and associated with the context namespace is the Spring Context 4.0 XSD schema. You then see a context annotation config that has registered the auto-wired annotation bean post processor, the common annotation bean post processor, the persistence annotation bean post processor, and the required annotation bean post processor, just by introducing that tag. So if you start to annotate your Spring Managed Bean classes, these bean post processors, because they're now registered, will be looking for those annotations and will attempt dependency injection. Now, there is one other annotational approach that we should be aware of to identify a Spring Managed Bean. We have a bean tag to say that employee service impl is a Spring Managed Bean, and we give it a primary identifier. What you're looking at here is the annotation equivalent at component. And if it doesn't have an argument like we have here, serve, it will use the employee service impl with a lowercase first letter as the primary identifier for this Spring Managed Bean. So that serve is actually the ID. So you can see the comparison between the annotational approach and the XML approach at the base of your slide. The at component annotation is called a stereotype annotation because you might have heard of at repository, at service, at controller. They're specializations. They may have additional attributes that their processors may be looking for. Now, putting at component on the top of each Spring Managed Bean may be quite tiresome. However, in order to pick them up as Spring Managed Beans and not have bean definitions in XML, you must have the first code snippet that I've got here. Component scan base package com.employee. That means in com.employee or any sub packages of com.employee, you will pick up as Spring Managed Bean and pass them through the relevant bean post processors any class annotated with at component. But as I mentioned, it can be quite tiresome. So you see this second code snippet, which has included two other types of tag, an include filter type and an exclude filter type. This is saying that indeed you will pick up any bean annotated with that component in com.employee and their sub packages. But even if it's not annotated with at component, it will still pick up a bean in the package com.anything core.anything. So com employee core, even if it's not annotated with that component. You will exclude, whether it's annotated with that component or not, any class annotated with the annotation com employee my annotation, or any class that is an implementation of the interface com.employee.my assignable. So we call these include and exclude filters. You've seen the regex one, the annotation one, and the assignable one here in an example. So very quickly, you can scan and pick up classes to be Spring managed. So let's look at our first Spring annotation for dependency injection, auto-wired. It's type driven, so it's injecting in a dependency based off type, like the type of class, or a subtype of the desired type, like a subclass of a class. It can be applied to constructors, fields, setter methods for normal injection, a method with an arbitrary name and arguments in which all arguments are auto-wired with a matching bean. So you can have a method that just takes 3 or 4 arguments, all of which are Spring managed. You can put auto-wired above that and it will execute after setter injection. It can be placed above collections or arrays where it injects all the beans of a type. So in that situation, if you had a list of employee service It will get all implementations of employee service it could find in the application context, assemble them into a list, and then inject the list. So here we have a component, employee service impl, and we have order wired above set down. You see employee DAO. So it's looking for a Spring Managed Bean who implements that interface. And sure enough, I have an employee DAO impl annotated with that component. It will pick that up through the relevant Bean post processor and inject it into the employee service impl courtesy of setter injection as it goes through the IOC container. AutoWired is a very useful annotation. As we've already said, constructors and even list arguments can be auto-wired in. Auto-wiring by type normally fails if there's more than one candidate. So if we had more than one implementation of employee DAO, it couldn't make its mind up and the application context will fail with an exception. However, if you are auto-wiring an argument that is a collection or an array, it will instantiate all candidates, put them into a collection, and inject the collection in. Much as we've done in our code snippet beneath, where we have this constructor with a list of employee objects, anything that implements employee class or a subclass of employee, like, I don't know, remote employee, would be assembled into this list and that list would be injected in. You can also auto wire a field directly, in which case you will not need a setter and you could remove that. We also have simple value injection, much as we had in XML. It uses the value annotation. Property editors will be triggered just as we saw with XML before. You can annotate fields directly and avoid setters and getters. And you can also annotate constructors. So here we have a couple of at values, true, at value 20, it's hard coded, we'll replace that in time. And here we have it in a constructor. Note that the at value can be used against the argument in a method or a constructor, as we've done here, at value name, at value 3456 int ID. I do need the order wired above the constructor because maybe you have more than one constructor. I've got to have Spring identify which constructor we want to use. So the one with order wired is the one we'd use. Now, as I mentioned, order wire will fail if there's more than one candidate that it can order wire into, say, a setter. We only want one, and a exception will be thrown, so sometimes it's necessary to implement more control over the selection process, and we can do this by the qualifier annotation. You can associate the qualifier attribute value with specific arguments in order to narrow the set of the potential type matches so that only one specific bean is selected. Let's take a look. So here I have two employee DAOs. I have a DAO null and I have the one I really want, DAO impl, and they are injecting into the employee service impl DAO. I have two candidates. This will fail. It won't be able to make up its mind which one to use. So we have some options for you. Option 1, name the property with the exact same name as the ID of the DAO that you want. So in my first code snippet, I called it employee DAO impl. Option number 2, introduce an at qualifier annotation to link the dependency bean's ID. So now I have an at qualifier on my property in the service when the value of the at property the at qualifier annotation is the ID of the bean that I want to inject in. Option number 3, introduce a qualifier annotation to the link the dependency to a beans qualifier. So now I've got a qualifier DAO impl. You'll see I've added a qualifier DAO impl to the DAO that I wish to implement. So we're seeing qualification based off ID, and also we're seeing it in an alternative approach using qualifiers from both ends. We also have a scope annotation. Remember we talked about prototype and singleton. Singleton's the default. If you put @scope, these will be lazily instantiated beans on a per request basis. So now we're going to look at the first of 2 JSRs with respect to JAVAX annotations. These are older annotations from the JSR 250. But you may still see them. You'll definitely see the lifecycle annotations, which I'll mention in a minute. Let's get the older one out the way first, the @resource. This has a name attribute which points to an ID of a bean that it wishes to attribute in. So it's telling you, unlike AutoWire, this is autowiring by identifier. It could be an alias, it could be a primary identifier. If it doesn't find it, it will resort to autowiring by type, and the same semantics we saw with autowired will take place. It's not as convenient as that autowired with respect to where it can be placed. It could be placed above fields and setters. No lists here or anything like that. The lifecycle ones, @postconstruct and @predestroy, are used more often. So I mentioned about implementing initializing bean. That has a method after property set, which you can implement, and that will be triggered after setter injection or after the before initialization method of a bean post processor. However, the @postconstruct is a more favorable way of treating an initializer. In an initializer, you could do any sort of logic you want that you couldn't do with annotations, like you could call a web service to get some data that you want to populate the state of the Spring Managed Bean, for example. But notice how the @postconstruct can be used above a private method. We also have a predestroy. Now, a predestroy is executed when the application context closes. This means your bean is becoming non-Spring managed, and as such, it has no connection with Spring anymore. So it's kind of like the finalizer method in Java, but only when it's becoming non-Spring managed. So it's not when it's being garbage collector. There is an interface, disposable bean, that you can implement, which has a method destroy, which is another way that you can do this. However, these lifecycle annotations are preferable because you don't implement interfaces and they can be used on private methods. The second JSR to talk about is JSR 330. This is newer, and this is all about the autowired equivalent. It uses an @inject annotation instead of autowired, and it has a means of qualification with an @named annotation. So if multiple bean types are available, then Spring will be unable to make a decision on which bean to inject and will throw an exception. In this case, you can do an @named with a value equal to the identifier of the bean that you want to inject in. It is also used @named as the equivalent of the @component annotation. So it has two purposes. Spring will scan for these annotations, just as we've done before with our XML configuration to do scanning. However, JSR 330 is not Spring, it's JAVAX, and the default with JSR 330 is to have prototype beans. So sometimes it's preferable to annotate your bean with the @singleton annotation to mark it as a singleton. So here we have our employee service impl. It's named, It will be the name of the class of the lowercase first letter unless I put a value attribute in, which I've done here. So it's now empl service. Otherwise, it would be employee service impl, the lowercase first letter. I've marked it as at singleton. It's not always required, but it's not a bad thing to do. Much like AutoWired, you can put @inject above fields, above setters, above methods, and you can see here I've used an @inject above a constructor, and I can also show you that I've got a qualification here on an @named on the argument for the employee DAO implementation that I want to use. These are probably the preferred annotations simply because they're JAVAX. There is no @value equivalent. However, if we go back to JSR 250, you can use the post construct to populate simple values for the state of ill managed being. Now, I should also point out that you can use JAVAX annotations and Spring annotations on the same class. The Beam post processors pick them all up. So you could use @value for your simple value annotation approach with respect to the simple values that you want to inject in through setters or member variables or constructor arguments.
Hello again. In this lab, we will use metadata to configure our Spring application. This is where we left off with very verbose XML, but we will be using annotations. In order to use the annotations, we have to register the various Beam post processors that scan Spring managed classes, beans, for annotations and take appropriate action, i.e. dependency injection. And we have up here a Spring context namespace, which is to do with that. It's the schema context namespace with its associated schema. So if we use the prefix context, we can see, for example, we can get this tag. I'll close it up, it's nice and neat. This actually registers 4 key Beam post processors for Spring. And if we do another context one here, we can start to talk about component scanning, where we're going to scan for both annotated classes and those that aren't annotated, but can be picked up using filters. Now, to save myself a bit of typing, I've actually put these in already. So I'm saying my base package is com.student. I'm going to scan for annotations in com.student and any base packages. Now, I'm going to have a little bit of a problem here because this is a Spring Boot application, and if we run our project and we pick up the student application class, which launches the Spring Boot application, we will launch a second context. So I need to exclude that. In a similar vein, student is a model class, an entity, if you like. It's not something that Spring manages. We return instances of student from our Spring managed service, for example. So we want to exclude that. And we're going to run our JUnit. So we want to exclude that as well. So I'm saying if you're assignable to student service test, I do not want you to be Spring managed. I'm going to run that myself. So basically we'll pick up com.student and we will exclude certain classes from that particular scan. So let's now start annotating our beans. Well, first things first, let's get rid of all the XML. Now we can go to student DAO impl and we can just annotate this with named. Make sure I get the JAVAX annotation. I don't have any other dependencies on this, So we're kind of done here. If I come into student service impl, once again, I want this to be named because I want it picked up by that scan. But I do have a couple of dependencies. So this first one is going to be inject. Now, inject will look for that bean that implements student DAO and inject it into it. Now, if we had more than one, we would have to qualify it somehow. We'd have to put something like named in, and we'd have to put in its ID. So what's its ID now? I got rid of the XML. Well, its ID is the name of the class with the lowercase first letter. Or, if I came into here and did student DAO, its name is now student DAO. Let's use that. There you go. The value annotation here can be used to inject in the number 2. It's hard-coded at the moment. We might do something about that later. I don't need these setters anymore. They can go. And that's my completed class. Make sure I save it. Everything's saved. Go back to my tester class. Is there anything I need to change here? Still using the same XML file, but it's very different now. Let's see what happens. No bean named student service available. I wonder why. Let's go take a look at the student service impl. What's the name of this bean? It's actually student service impl. You know what? We can do student service because that's what we use in our JUnit. That's what the exception said. Save it. Run it again. Let's see what happens this time. Looks like I just got 2 students, so the value annotation worked. Looks like I picked up my DAO. Looks like that worked. My JUnit's good. That's it. We've now achieved dependency injection using annotations. Very easy, very quick.
Lesson 5, Java configuration. Here we will create Java configuration classes, remove the XML dependency we still have with annotations for the annotational scans completely, and we'll also write JUnit tests in classes that become part of the application context. So as of Spring 4, there is a way to configure Spring Beans in Java while still decoupling the configuration from the managed beans themselves. So here we're going to externalize the configuration again. The central artifact is a Java configuration class annotated with @configuration. It will take the place of the XML configuration file completely and omit it for the final time. Annotating a class with that configuration indicates the class is being used by the IOC container as a source of bean definitions. It will have a series of methods, sometimes called factory methods, annotated with @bean. These are our bean definitions. So here you can see an @configuration annotated class, @config, and in there there is one bean definition annotated with @bean. Now, a couple of things here. The ID of this bean definition is the name of the method getEmpl-serve. In that method, you can do whatever you like. Here we create a service impl and inject in a new instance of an employee data impl and then return the service. You have the whole power of Java to do whatever you like in this method. You can see the XML equivalent beneath that we are achieving. Here, I've changed things up a bit. Employee service now is being created by, again, a factory method called getEmpl-service, but I've changed its ID to be service courtesy of the name attribute on @bean. I also have an init method equals init. This is like the post construct in JAVAX annotations we saw before, an initializer. The next thing to point out is I have a second bean definition that creates a new instance of an employee DAO. This is now a top level bean in its own right. You can go to the application context and get a bean whose ID is DAO, and you'll just get the DAO impl. Notice how I'm setting the DAO in the Empl-service factory method by calling the method that returns an employee DAO impl. So this is dependency injection at work across two bean definitions. We need a different type of application context because we're using a different metadata now. There's no XML. And we have one called the annotation config application context. It recognizes @configuration classes. It actually recognizes @component classes as well. So we can use @configuration classes and or @component classes as input into this new type of application context to create the overall IOC container. So here's an example. I'm creating an annotation config application context with one configuration class. I'm just getting the bean, in this case, by type. Beneath, I'm getting another annotation config application context, but this time I'm not just putting in a configuration class. This time I'm putting in two component classes, employee service impl, employee DAO impl, and I'm getting the bean by type again. Annotation of bean post processors are registered by this type of context. As such, it recognizes @orderwired, @value, @inject, and named. So we can use those annotations in the configuration classes themselves. So here I'm bringing in employee DAO from somewhere, and I'm using that to inject it into the service input in its factory method. I'm also bringing in an @value. Now you see that little $sign there, min in squiggly brackets? That's an EL expression. We're going to see that in a future lesson, but it's bringing in a simple value to inject into this factory method. Where does employee DAO come from? Well, it comes from another configuration class in this case, or it could have come from an @component if that was part of the input to the context. Now, the advantages of this Java config: it's written in Java, it's type safe. As such, the configuration is checked at compile time, not at runtime when we parse the XML. The bean factory methods have the whole spectrum of Java to use to create your bean. XML can be very tricky to write, but we have great editors for Java. In a pure Java configuration, all annotations will be removed from your application Spring Managed Beans. So there is no Spring dependency anymore on those annotations, as the configuration is 100% external. However, you could leave them in if you wanted, and those annotations will take effect because you have the same bean post processors that you have always had. So you can mix and match. The last part of this lesson is talking about testability. The Spring Framework provides Spring-specific annotations that you can use in your unit tests, courtesy of the Test Context Framework. The annotations include here the context configuration annotation, as we will see that we place on our JUnit to load an application context from somewhere. The context configuration declarations can either be for an XML file where we would use a resource location or for configuration classes. Let's take a look. So with JUnit 5, we just extend the Spring extension to be a JUnit that is Spring aware. Right away, that Spring extension says, I need an application context built. Can someone tell me where I get my metadata from? And we have the at context configuration annotation. And because we're using the attribute locations, we can have one or many XML files to bring it in. This approach allows you to have a Spring managed JUnit, and you can use the same annotations you've always used, JSR or Spring, Resource or AutoWired, to inject in beans from that application context. Now here, I've used an at context configuration with classes, not as we did before. This means I need configuration classes in a comma delimited list or components. And as I mentioned, the JUnit is part of this new context, so the at inject will pick up the Spring managed bean that implements the employee service and will inject it in, making your JUnits really simple. Our applications are now 100% XML free. We no longer need an XML file. And our JUnits no longer need to create an application context. It's created for you by these annotations. So we can get rid of all that code and just inject in the dependency that we wish to delegate down to.
Hello again. Here we are in our lab. So this time we're going to change the metadata again to use Java factory methods as a means of configuring our Spring application. So let's start off by creating a brand new class. And we're going to put it in the package com.student.config, and the class is going to be called application config. Okay. Probably not needed because we've only got one, but we're going to annotate this class with the Spring annotation configuration. Now we'll define our factory methods, which are effectively our bean definitions. So we will return a student DAO here, and we'll call it student DAO, the method. That's actually the name of the bean definition by default. Return new student DAO impl. Make sure we have everything. And it's a bean definition. So we'll put bean above it. Spring needs to see it, so probably make it public. Now our second bean definition is a little bit more complicated because it's the service and it has two dependencies. So let's go get that first dependency. I'm going to annotate a property in this configuration class 2. private int number of students. Okay. Now I'll create the next bean definition. Okay, it's going to be for student service. I'll create an instance of it. Now we've got to get both the DAO and the number of students into this student service impl class. Now in the last lab we took the setters out because we were using annotations. Before we can go any further, we have to put those setters back in. Now while we're here, a couple of things. We can get rid of these annotations now. And I'm going to keep a note of that named student service. Let's come back to here. It's called student service. We're good to go. Or if you don't want to do that, let's call this something else. Make it clear we can give it a named attribute. All right, now we've got those setters. Let's see if we can pick them up. Well, we're still at the interface type here, but we're inside a configuration class. Don't want to expose setters through the implementation interface class, so I'll do that. Haven't left the factory method yet, so I think we're okay. And it's even prompting me, isn't that nice? Make sure this is right. This is actually calling a method to actually do the injection. A bit tight there, so we'll do that. I've got my beans, I've got my configuration. I can save it. Before I go to my test class, just going to come in here and say goodbye to the annotation there. We're trying to externalize as much as we can in our Java config approach. Okay, now let's go to our test class. Now we've been using this. This has to change now. To a type of configuration that can take a configuration class as its metadata. That's an annotation config application context. All right. Finish that off. We also want to implement this method a little bit better. So let's do student equals service get one student from it. It's get method. Let's get number 1. And let's do assert that student dot get first name is equal to Eric. So I have my new context, have my configuration class. If I run this now, let's see what happens. Looks like it's worked. JUnit's green. One more thing to do. This Beans XML, remember this guy? He's history. He's done. We don't need him anymore. You can delete him if you want. Let's run that JUnit again. There we have it. Java config of a Spring application. So that's the end of this lab. What we're going to do in the next lab, we're going to make this JUnit even easier for you. There's too much code in here for my liking. Hope to see you then. Hello again. In this lab, we'll be working in the test class only, making it Spring Managed in its own right so it can have Spring Managed beans injected into it. So we'll start off by using the extend with JUnit 5 extension. And this will actually create an application context, but of course it needs metadata. So we're going to tell it where it is. By using the context configuration annotation, pointing to our Java config class. Okay, so what we can do now is we can basically do an inject in to the JUnit itself because it's Spring Managed. We don't need that. We don't need that. We can save our test class, run it. Looks like that worked. Looks like this other one worked. There are 2 students. So there you have it. JUnit made very simple. Part of its application context that it creates through the extend with Spring extension, making testing really easy. So that completes this lab. Lesson 6, Externalized Configuration. Here we will use property files for configuration data to define literals that can be used by expression language or EL in our @value annotations rather than having hard-coded values. We'll define Spring provided managed beans, ones that we haven't defined ourselves, and we'll use Spring Expression Language or SPELL for powerful expressions used with, again, @value. When we read a properties file, we need a bean to do that, and the bean we could use is property placeholder configure. I have a bean definition for it here. It has a class path resource, a resource class that can read the properties file, and it becomes part of the application context. Which means that a properties file with active and count, as you see here, it looks as if our dollar squiggly bracket expressions are pointing to those key value pairs, and conversions will take place. That is somewhat true, but in fact, the property placeholder configure is reading these key value pairs into the Spring environment object. And active and count are going to the Spring environment object, which is like a glorified map to get the values of those keys. Now that class is deprecated. We actually use a property sources placeholder configurer. You can see the definition of it here in a Java configuration class. You should note the static. This means this bean definition will execute before any non-static bean definitions. I want that to happen because I may have the other bean definitions use items from the Spring environment object that were populated from a properties file. Now, where's the properties file? This class is associated with an @property source annotation, which has the value of the properties file. Now, if we're purists, we want to get rid of the @value annotations within our domain classes, we will put them in our Java configuration classes. Here, we're using them as a method argument or as a member variable. Which way you go depends on scope. Whether it's going to be used exclusively by one bean definition or not. Spring Expression Language is significantly more powerful than EL. EL is just literal replacement. Here you can actually execute code if you like. For example, here I'm executing the random method on math, and I can use it in both XML and within @value annotations. SPELL has the ability to locate Spring managed beans. Its syntax is ID, ID property, ID method. So hash employee service, get me the bean with an ID of employee service. Employee service.employees, execute the method get employees. Because there's no parentheses, it's implying it's a property and therefore it's looking for a getter. Employee service all employees, no parentheses before, but here we have the parentheses. It means we're going to execute the method all employees. It's not going to suffix get in front of it. So for example, @value hash employee DAO, get me the bean with an ID of employee DAO. @value employee service .DAO get 1L, get me the bean whose ID is employee service, execute get DAO, execute the method get 1. Now we can use SPELL in expressions to filter collections. So we can do sub-collections of collections within our application. We can use SPELL to filter a map, for example, into a collection, such as a list of employees within a department. So here's my map. Here's my employees in department. I'm going to look for a bean whose ID is employee DAO impl. Execute the method getMap. There it is. Get its values. Dot question mark means I'm going to filter all the items within values. Execute the method getDepartment because there's no parentheses. And if the department equals 7 long, it's going to be part of this new list of employees. We can also filter to get one item with the caret and the $ to get
either the first matching or the last matching out of a collection and inject it into a single item dependency, such as just a single employee. And here we're actually combining both EL and SPEL. Get me all the values from the employee DAO import get map method, filter it using get department equals, and then we see dept in dollar format. That's EL getting the property dept from the Spring environment object. And that would get me all the employees in that department, whatever the value of the department is. But I do dot first name at the end. I just want to get the first name out of the first item within that map. So we can really build our expressions quite extensively. SPEL also has access to system properties, such as the operating system name with the system properties predefined expression. Now, in our test that we do in JUnit, we can define an application context initializer, set up values to use in our application context. By that I mean we can set some system properties. If I implement the application context initializer, as I've done here, I'll override the initialize method, and here I've set a couple of system properties. When I come to my testing on JUnit, everything's the same as before, extend with context configuration, classes, my application config class, but I've added one or more initializer classes, which means I can inject into my JUnit system properties. In this case, the key is my property, because that's a custom property that I set in system properties. Now here's a great example. Value equals system properties, operating system name. Does it start with Windows? If it does, return hello Windows. Otherwise, return hello other. We're basically doing an if-else in an expression. Now, we're extremely complicated. It is best to execute a method on a Spring Managed Bean to do such things because you have type safety in Java. Hello again, here we are in our lab. We can use expression language as part of our configuration. I've got a couple of properties, max and department, in my application properties under the resources folder. Now the next thing I'm going to do is in my application configuration, I'm going to add a static bean definition for the property sources placeholder configurer. Static because it needs to execute before anything else. Property source will tell it where the properties file is for that bean. Once we have that, it'll read it, it'll populate the Spring environment object, which means down here I can use the expression max to populate the number of students for our existing student service. The second part of our lab is to do with SPEL. So in SPEL, we're going to add this property, students for department. It's got a getter for it. And you can see it's got this SPEL expression, student DAO get all. So student DAO, what's that? Well, if I go to my application config, I can see that my DAO here was the name of my bean definition by default. You could call that student DAO if you want, or you could use the name attribute of the bean definition, whichever you like. So that means when I come back to my
service implementation class, the student DAO is an ID of a Spring Managed Bean. If I didn't put the name there, it would be DAO. Since I put the name one in there, I'll keep with student DAO. And then it brings back a collection of student objects. So if I look at student, it has a dep property with a getDep method. And since there's no parenthesis there, unlike here, this is actually saying execute the getDep method on each item in the collection returned by getAll. And if it equals, and here we have a spell, the spell expression is nesting an EL expression. Department, that was in our properties file, English literature. So since we have this here, we better expose it through our interface. Make sure I save everything. Then I come to my test class and I've added a new test students for department. Get students for department, size, it should be equal to 2. There should be 2 students for English literature. How do I know that? Because Eric and Jason are the only ones in that department. So if we run this, we've got green, students for department, the cert has passed. And there's the output from the getAll where we're using the max property just to get 2 students back. Lesson 7, conditionals. Here we will understand the need for conditional beans in your development pipeline. We will use a series of predefined conditionals from Spring Boot in your applications. By doing so, we can make your configurations more dynamic, as for example, you might move through your pipeline from a test to a production environment. We may want to exclude certain cross-cutting concerns, such as logging in production, which would lead to excessive logs for our applications. So we might want to do that in tests, but not in production. We have conditional annotations that allows us to define custom conditions to apply to parts of our application as well, and predefined ones from Spring Boot. We'll use both in this module. Anywhere we define a Spring Bean, we can apply a conditional. Only if that conditional is satisfied will the bean be included in the context. We can apply these conditionals both at the bean level or the factory bean definition level. That's where we'll put ours. We have predefined conditionals from Spring Boot. We're going to look at some of those here first. Conditional on property allows us to load beans based off an environment property. So for example, the value env in Spring Environment class must have a value of tests for the service employee service impl to be included and proxied. In fact, we can also say if there is no env property in the Spring environment, then include it anyhow. So it's kind of like a default. Normally we would be very strict and just say it's got to be included if this environment property is present and of this value. If it's not, don't include it. Conditional on expression. The expression just needs to resolve to true or false for the annotated bean definition method and the subsequent bean to be included in the context. You can put anything in an expression. As I said, it just needs to resolve to true or false. The conditional on bean. In this situation, we're only going to execute the bean definition method if another class is present in the Spring application context, such as employee.dao.class. We can do exactly the same thing, not using the class, but using the bean name of a Spring Managed bean. Conditional on resource, we're only going to load the employee service impl if the resource application.properties is present. We can define different beans in our application context with different conditional on annotations, such as conditional on resource, whereby we're only going to load those beans whose conditionals resolve to true. For example, if I only have one application properties file and it's called application properties, I will load this service. If I have another bean definition that says load this bean if it's application super properties, if that resource isn't available, it will not load it. We can start to combine conditionals. Here we're using a conditional on property and conditional on resource. Everything has to resolve to true in order to include employee service impl. Or we can start to create compound expressions. As I said, you can put anything in an expression, just has to resolve to true or false. The main driving force behind here is you have beans with the same name, which we know we can't have in an application context. They have to be unique, but the conditionals ensure only one of the two beans with the same name will be included in the context, so we don't have a problem. We can create our own condition classes. We just have to implement the condition interface. It just has one method, matches. It returns true or false. The context gives you access to the environment. The metadata can tell you what data is being used within your annotation. So here I'm using the context, go to the environment, get the property env. If it's equal to prod, then this will return true. Once they have that in place, I can use our conditional annotation to point to that class. The employee service here will only be included if that matches method inside that class employee conditional underscore prod returns true. We get extremely selective now on what beans are included because that matches method is in Java. You have all the syntax and power in Java to determine true or false. Hello again, here we are back in our lab, and we're going to use conditionals to dictate which type of bean definition we use in our configuration. So we have this student service proxy class, it's got a logger, and for the get all students and the get by ID, we can see we have some logging activity. More importantly, it's delegating down because injected into it through its constructor was the original service that we've been working on so far, the original service implementation of the interface. Note both these implement the same interface, they would look and feel like the same thing to the outside world. So we gave you that class. So the next thing was the application configuration. Now in the application configuration, you had your original bean definition here, and we asked you to bring in either replace the configuration with the one we provided or to type what I've got highlighted here in for the proxy. So notice that we're wrapping the original service impl inside the proxy. They both implement the same interface. They're both implementations of student service. Now, right now, we would have an issue because our test class says I need a student service. Well, I now have two, not one. And it can't make its mind up. It would say, hey, I can only have one. So we have to somehow filter one out. And the way we do that is in our configuration. We
put above here a conditional on expression, a provided conditional, saying that a piece of EL, a property in the Spring environment called env, is equal to prod, then you include this. Same sort of conditional expression here, but env, a property in the Spring environment, if it's equal to test, you include this. So where is env set? Well, if I look at application properties, it's right there, it's test. So when I go to my test class, one of those beans have been omitted, and there is only one candidate to wire in. And if we run this, we'll see some red logs. Those red logs are the logging, like for instance here with get all students, and here for getting an individual student. The key here was logging in the proxy, then delegating down to the real implementation. And the real implementation, which is the whole point of the proxy pattern really, is that it's no idea that it's basically been advised with logging before it got to it. So we might want to use this for debug. If we're pretty confident that everything's working, we don't want to clutter up our logs, we can just change this to prod, and we just run it again. And again, this time we'll exclude the proxy implementation of our service interface, and there won't be any logs in red. Well, that completes this lab. In the next lab, we'll be looking at making our own conditional, and I hope to see you then. Thank you. Hello, this is our Spring MVC, Spring Boot, and REST Controllers course. I'm your instructor, Derek Parsons. I'm wearing my hiking hat, and I look very hot after a long day in the sun there. This course is made up of 3 modules. Each module will have 1 or more lessons. In our first module, we'll talk about Spring MVC as the framework. We'll see how Spring Boot makes life easy for us. We'll create some simple REST controllers, and we'll customize the Spring Boot application through various configuration techniques. In the second module, we'll talk about extracting data from the HTTP requests as they hit our REST controllers. We'll talk about how we push data or post it to a REST controller. There'll be some time devoted to content negotiation where services negotiate on what format their response payload should be, JSON or XML, for example. And then we'll talk about clients accessing our services. We'll use Java clients with REST template, and we'll also take a brief look at AngularJS accessing our services. Our third module will contain the creation of a controller, not a REST controller. Here we'll be rendering a view in a more traditional web application. And again, we'll be showing how the Spring MVC framework is abstracted away from us, courtesy of Spring Boot. So why don't we just jump straight into Module 1. See you there. Welcome to our first lesson, which will be concerned with the Spring Model View Controller or Spring MVC framework that provides the basis for Spring Boot. We'll talk about the Model View Controller pattern. We're going to talk about the role of the dispatcher servlet within the Spring MVC architecture and how it implements the front controller pattern. We're going to talk about understanding the roles of the key players or helpers to the dispatcher servlet with respect to creating a Spring web application context. So let's talk about MVC. It's a design pattern where there's a key separation of concerns: the model, the state, the data, the business logic of your application, a view, presenting data to the outside world, such as JSPs, screens, stuff like that. And a controller. A controller acts as the go-between to interact between the model and the view. Requests come into the controller, it will decide what to delegate down to. In terms of the model, it will decide what view to go to next as a response. In rare occurrences, we do have situations where the view and the model do communicate with each other directly, but that's rarely done nowadays. In front controllers in the Spring framework, we have one, the dispatcher servlet. The dispatcher servlet follows the front controller pattern in that all URLs go through this single point of contact and entry into your application. Through configuration, it will delegate down to subcontrollers, which will interact with the business logic of your application. Those subcontrollers will return data, which is actually also referred to as the model, to the front controller, and the front controller will make decisions on what view to render and send the data received to that view for display. With Spring MVC, it was developed with this key separation of concerns because originally, when we were looking at Java EE MVC architectures such as Model 1 and Model 2, as I've listed here, there were many shortcomings. So let's talk about those shortcomings. Number one, in Model 1, basically the model, view, and the controller, they could all talk to each other. That was cleaned up to represent what we now know as MVC, Model 2. But with Model 2, the implementations of the controllers, there was massive duplication of effort. Logic to receive requests, logic to dispatch to a view. So the goals of MVC were to simplify the task of creating web applications, create front controllers, or a single front controller in our case, that would take care of the generic stuff, such as I can get data out of the requests coming in to the web application, and I can give it to the subcontrollers. If you tell me where to go, I can implement the logic to dispatch to a view. Based on MVC, the key separation of concerns resulted in a means to easily integrate with the Spring Core module part of your applications where your business logic were based. As we will see, it's very simple. We have two contexts, a web application context and a root context that can talk to each other. That's what we're going to talk about here. A dispatcher servlet needs help, and that help comes from key players in what we call the web application context. That web application context is all about creating the dispatcher servlet, the front controller, and delegating down to subcontrollers or REST controllers as we call them. And from those REST controllers, we will delegate down to a second non-web application context, often referred to as the root context, where it's not concerned with web components, it's concerned with Spring Core beans. Subsequently, these guys can communicate with each other quite easily through dependency injection. So this is the web application context. Let's take you through it. A request comes into the dispatcher servlet because all requests come into the single front controller. It is going to be configured through metadata in Spring to get to a controller or REST controller. It achieves that through a cross-reference, where this URL goes to this method in this controller or REST controller. So we map requests to controller methods. It then is going to delegate down to the REST controller. It has to do something. HTTP is completely textual, so if you've provided data with your HTTP request, it has to convert that data into a Java type to inject into the method of the controller. Conversely, when the REST controller responds or the controller responds with a response, it's going to have to go through the handler adapters again to convert the Java type that it's responding with, maybe a Java bean, into text to place into HTTP responses. Once that response is sent back to the dispatcher servlet, it's going to use its dispatcher to select a view to go to. That is achieved through a view resolver. Or it's going to write directly to the response object of HTTP. If anything goes wrong, we have an exception resolver to generate some sort of error and respond accordingly to the requester. So the major players again: handler mappings, URLs mapped to controller methods. The dispatcher servlet will delegate down to the controller method or handler and execute the logic there. The handler adapter is used to actually invoke the controller method, converting input parameters to Java types and responses from those methods into textual representations, JSON or XML. An exception resolver: if something goes wrong, I will throw an exception. I need something to deal with that. The resolver will locate a built-in simple mapping exception resolver to generate some sort of HTTP response. The view resolver: where do I dispatch to after the controller method has responded back to the dispatcher servlet, or writing directly to the response, the data that was sent back, such as JSON, to the response object. And then, of course, key to all this are the subcontrollers in the front controller pattern, the actual controller or REST controller, which has the functionality that we're invoking and is our gateway into the root context where all your business logic is. These are auto-detected through package structure. Welcome to lesson 2. In this lesson, you will learn about how we can create Spring Boot projects and with minimal configuration get a web application up and running, understand the structure of a Spring Boot project, why it's so important, see how the Spring MVC framework is abstracted away from you with opinionated default settings so you can create something very fast. So the goal here is to provide a Spring Boot project quickly, not get bogged down in the details of the Spring Web Framework, provide features with minimal configuration. What you must understand here is it doesn't generate code. It will wire up the web application context that Spring's dispatcher servlet needs for you with default configurations behind the scenes. If you want to override those defaults, you can provide your own configurations quite easily. We can also simplify the means of dependency management by using Maven and Gradle to bring in all the dependencies needed for a Spring Boot and therefore a Spring MVC application with minimal configuration of perhaps a Maven POM. There is a website out there which you can go to, start.spring.io, where you can generate a Spring Boot project. You'll see something like you've got here. Dependency management is quite critical. You can search for dependencies on the website and bring in what we call Spring Boot starters. So for example, I'm bringing in the Spring Web Starter here, which will bring in, once we deploy our Spring Boot application, by going out to Maven Central, all the dependencies needed for a Spring MVC project. So we select the Spring Boot starters we want. We decide what project type we want, Maven or Gradle, whether it's Java, what version of Spring Boot. We click the button, Generate Project, that you'll see at the base of the website, and you'll get a zip file. When you unzip that file, perhaps in Eclipse, you will see the structure that you've got here, all generated for you. We need to go through this structure because it's the basis by which it's making its opinionated defaults for your configuration. If you look at the Maven POM that you have, you'll see the Spring Boot starters, such we have the parent one to bring in Spring Boot starters dependencies, all the jars needed for Spring Boot. And because we were using web, we have another entry to bring in all the Spring MVC jars. If you look at your class path, you will see a profusion of jars that have been brought in as courtesy of these Spring Boot starter entries in your POM, rather than listing them all in the POM, where the POM would end up being enormous. In our generated project, we will also see an application class. Here it is. Note the Spring Boot application annotation. If we look at that annotation in its source code, we will see that it is annotated with configuration, enable auto configuration, and component scan. So let's talk about enable auto configuration. That is saying I want all the opinionated defaults. Hey Spring Boot, create me a Spring MVC application. That's all you have to do. Everything else is taken care of in creating the dispatcher servlet and its web application context. The second annotation is a component scan I want to talk about. That is saying, well, the dispatcher servlet, the front controller, is going to delegate to subcontrollers or controllers, or REST controllers as we call them. Where are they? Well, they're going to be in the same package as this application class or sub-packages thereof. And then the last annotation configuration is saying that this class, this application class, can act as a Java configuration class where you can define bean definitions. By launching this class, this runnable class, you are going to launch your Spring Boot application. The structure then. So from the top, we have our application class. You can rename it. We then have source main resources. Underneath that, you will have a static subdirectory. It is here that the default configurations will look for style sheets, JavaScript files, images. If you have the Thymeleaf HTML5 dependency brought in by your POM because you stipulated that starter, your view resolver that the dispatcher servlet has to say which view do I go to is going to look in the template subdirectory for HTML files. So if my dispatcher servlet delegated down to a controller and that controller returned home, it's saying you want to go to the source main resources templates home.html page. Take me there, dispatcher servlet, because you have a dispatcher. You will also have configuration files. They will also go under the source main resources directory or a subdirectory called config. You will also have a basic skeletal test class generated in your source test Java directory. You also have your Maven POM with your starters, and you will also see the Maven dependencies directory. If you open that up, you will see all the jars that were brought in by the Maven POM when this project was built through a Maven build. You also have an embedded Tomcat server. By default, the embedded server will listen on port 8080. Under the hood, Spring Boot has created a new type of web application context, an embedded web application context, which is basically looking for a factory class that will create an instance of Tomcat for you, which will be completely auto-configured. Although we can deploy Spring Boot applications as WARs, more often than not, when you run the application class, you're effectively creating an executable jar which is being passed to Tomcat, and it will execute it on this embedded server. This makes Spring Boot extremely attractive for virtualization, such as Docker with Kubernetes, where the Docker images contain everything, the executable jar with its embedded server. So there's no deployment to a server here for us. It's done automatically when we run the application class. Okay, we're going to break now and have a lab. We follow the lab instructions. It'll tell you a little bit about setting up your Eclipse for Maven, and it'll have some brief lab instructions. It will tell you where the starter project is. We're going to use a starter project rather than generating one from Spring IO. You're going to make some changes there. So follow those instructions. You'll deploy it to an embedded Tomcat server. I'll walk you through the lab once you've completed it. So I'll see you on the other side. Welcome to lesson 3, defining REST controllers. Our objectives are to just briefly talk about REST, or representational state transfer. Create a REST controller and interact with a Spring Boot configuration file, and return some simple data from a REST controller. So let's talk about REST first. It's a software architecture for distributed systems to talk to each other, such as on the web. Roy Fielding is the father of REST, as defined in 2000. The REST style of architecture consists of clients talking to servers. Clients initiate a request, sends it to a server, and the server responds. Requests and responses are built around the transfer of representations of what they call resources. So a representation of a resource is, I am going to send you some textual data, frequently in the form of JSON or XML, and you're going to respond with a representation of resource in JSON or XML. A resource is basically anything that you wish to address on a server, typically a document or a representation of that document. We don't send the actual document back, we send back a representation of that document back in textual form. Unlike SOAP, REST strictly uses HTTP. SOAP was using it as part of its overall architecture. Let's take a look at HTTP. It's very simple. You must remember that it's textual. It consists of information stored in headers and a body. We can see here a request being made to a particular HTML page, index.html, using an HTTP GET method. I'm getting a resource back, a representation of that resource. In fact, it's going to a host called abc.org. I'm using Mozilla as the client, and I'm saying here that this client will accept a representation of the resource in the following media types: text HTML, application XHTML or XML, and that we will favor text HTML over XHTML and XML. That's what those numbers mean at the end. Giving my locale, and it will accept zipped up representations of resources for efficiency. Here's my response. It's saying that it's passing back a status code of 200, which is okay. And since we favor text HTML, we are getting text HTML back. And we've got a line break, and then we have the actual body of the message coming back. So it looks as if HTTP has specific methods. These are HTTP methods that you might be familiar with. A get means I'm getting a representation of a resource from a service. I would like to get all the students in the department. The students in the department may be Java objects on the server, but I need a representation of that, a JSON representation of that collection. Head is almost identical to get, but basically you're just passing back a response in headers. There's going to be no body coming back. So we might interact with a service just to get headers back. Post means I'm pushing a representation of a resource to a service where that representation resource itself does not exist. So I'm pushing something new. Put is saying I'm pushing a representation to a server for a resource that does exist because I essentially want to update it. I think delete is self-explanatory, and a patch is much like a put, but it's partial modification to a resource on a service. We create HTTP requests that go through the dispatcher servlet that use the defaults of a Spring Boot application to say, aha, this URL wants to go to this controller. Spring MVC annotational based framework is based off REST requests. The Spring Boot application class annotated with @Spring Boot application will scan for controllers or REST controllers annotated with the REST controller or @controller annotation and say these are the places I want to dispatch requests to. It will map URLs of an HTTP request coming in to the request mapping of a controller, and then map the method that HTTP was using to a particular method within that controller. So here I have a REST controller saying any request coming in at all into this web application will come to this controller. If the URL is not concatenated with anything else, it will go to the method string home and return hello. Otherwise, it will do URL concatenation to say, oh, you passed me in /abcd. I come to the home controller because everything goes there because it's just slash. And then I look for something that's an HTTP get map method. There it is, get abcd. And it's saying concatenate abcd onto the URL that I mapped to. So if you pass in /abcd, you will return world. Note the request mapping on the class and the get mapping on the methods. Each URL is mapped to an individual resource on a server. Our resources here are controller methods that are returning data. They must be unique for REST, those URLs that resources are tied to. If we start up our Spring Boot application, you will see the log as we've got here, and we will see the Tomcat server starting, and it will say, as you see down the bottom, Tomcat started on port 8080 with a context path of nothing. So that's a context root of a web application, like a qualifier, if you like. So if I type in localhost 8080, if you remember, 8080 means there's no concatenation of a URL be on the default URL, so to speak. So that means I will be mapped to home controller and the method home. If I type in /abcd, I will be tied to the home controller and the method getABCD. And you will see that those controllers respond, passing back to the dispatcher servlet. And because it's a REST controller that I'm using, it writes what was returned from those controller methods to the response object in textual form. Here's just simple string, so I'm pretty safe in that my string in Java can be converted to a textual string. It's written to the response object, and that's what's returned to the browser. Hence you see the two responses you see here. So here we have a situation where we want to get hold of maybe some parameters passed in from the request. You see a query string. So let's take a look at the URL. I'm mapping to a controller called myHeader. It's then being concatenated on param. Do I have a method mapped to myHeader param? Yes, I do. It's called getParameter. The request argument is okay. Spring Boot saying, I know what that is. Don't worry about it. I'll inject in a handle to the request object. We can get the parameter employee and get Mary and return hello Mary. We have other ways to do this that are far more convenient. We'll see those later on in the course. Now we have this configuration file under source main resources called application properties. We want to use it to customize the default configurations. We won't do much here initially, but what we'll do, we'll put in a couple entries called greeting and salutation. Note the expression language, that's a placeholder and it's resolving in the properties file. Hey, there should be a property called greeting. Could you inject it into this placeholder for salutation? So salutation will actually be hello world. We're actually going against the Spring environment object. This properties file is being parsed and read into the Spring environment object, which is like a glorified map. And we're actually going to the Spring environment object and say, is there a property called salutation? Is there a property called greeting? So what will happen now when we access this controller request mapping employee that you see here, and I pass in 8080 employee, it's going to go to this controller and look for a get mapping. There it is, get str, and it's going to return str. The at value annotation is using el to say go to the Spring environment object, find me a property called salutation, injected it into the employee controller so we can return it, and it should return hello world. So let's talk about dependency injection in Spring. Injecting in a dependency, wiring up an object graph. You probably saw that in our Spring Core module where we wired up object graphs of simple beans. This is where we transgress from the web application context to the root context in a Spring Boot project. The root context is non-web stuff. The web application context is everything the dispatcher needs, such as controllers and REST controllers. So we're really transgressing from controllers to model parts of our application. The way we do this is we simply inject in a bean from the root context, such as employee DAO. We could use autowired, we could use inject. We're now moving from one context to the other, so to speak. We're moving from controller to model. And what happens here is that when this REST controller get mapping mapped method is executed, get all, it delegates down to the model, the DAO, and executes the method get all. This will return a collection of, I guess, employee objects. Now I can't send employee objects back through HTTP. I have to convert them through the web application's context helpers into text. That text, because we've put a produces media type application JSON, which is actually the default based off the class path of the POM, it will convert that collection into a JSON array. So here you see the response in the browser. The browser is saying, I got JSON back. Okay, we're going to break here and do a lab. You're going to build upon your existing project to access some simple data that we could return back with a request to a REST controller. Follow the lab instructions, make sure your Maven is set up, and I'll see you on the other side. Here we are in the lab again. Your application's running, I think I'll stop it. So in this lab, again, I'm going to look at the solution. I can't type quick enough. We're going to work in Student Controller. And we're also going to bring in our service, which delegates down to our DAO. So let's take a look at what we had to do here. So in the Student Controller, we would have annotated it as a REST controller tied to the request mapping of student. We have a method getMessage here, which we would have tied to a get mapping and to a path, which is the default attribute of message, MSG, which returns message. Message up here is going to be populated through an EL expression. That comes from the Spring Environment object. So how do we populate that? You went to Application Properties and you basically said message equals hello from there. Then you put some more EL in to controller. So the message should say hello from the student controller because this is a placeholder which will inject this value into here. So that's what should be put into the Spring Environment object, and our EL should put it in there. So that message should be returned from there. Then we ask you to inject in from our root context the student service. The student service is an interface. We're looking for an implementation of it. It is named. It will be picked up in component scanning because it's in a sub package of the student application class, which is const student, and here we're const student service. It has injected into it a DAO, an interface, but we have an implementation, so it'll pick up this one. Again, it's a named bean, which has the methods getAll and getOne, which gets students from this map. So we've now brought that in. So we've tied our web application context to our root context, and we give another get mapping. So now we have two endpoints, student message and student. Now before, you had your student application class also as a REST controller. The final bit of the lab was to change the implementation of your home method. Your home method is now going to return a new redirect view, a redirect of a request that comes into slash, which is everything, and it'll redirect it to student message. So if we go to student message, we should be returning the string here. So why don't we run this? Give myself a bit of space. Run the application. Starting up. Looks like it started. Tomcat started on 8080. So let's type in localhost 88. It's even remembered it, look. Now, we typed in localhost 8080 and you can see I've been redirected to student message. And that was because of the change we made in the application class. This thing here. This came into the student controller. Message came from this class member variable, which used message from here, an EL expression through to the Spring environment object, which is populated from this properties file, as well as system properties elsewhere, but this is part of it. The message said hello from there. It had EL pointing to a second key value pair where the value was student controller, and we're good. Now we had a second endpoint in our student controller that delegated down to the root context to get all students. It returns a collection of student objects. Remember, we had our student class down here with lots of good properties, public headers and setters and things. That's where they are. So when we type that in, which will just be tied to the URL student, Firefox helps that, we can see our students being rendered in JSON format. There's Eric, Mary, and so on. That is because our class path has Jackson jars on it, pulled in by our starter files, which means that the default for rendering Java objects that are returned and injected into a response entity and returned to the client, in this case the browser, is to render those objects into JSON, in this case a JSON collection. So now we have a real web service getting all our students. So that completes our lab. So we'll move on to our next module, where we'll be talking about more aspects of REST controllers. Thank you. Welcome to lesson number 4, using properties. Here we will look at the Spring environment object, see how we can customize our application. This environment object can be configured using the application properties file, but also another file, application YAML, which uses a different form of notation. We will also show you how to set the values of predefined properties in either of these files, application properties or application YAML, in order to customize our application. And then we'll look at Java configuration classes, where we can populate these classes and inject them into controllers in order to get hold of configuration data that we can use. We've seen the application properties file. It's under the resources directory. More often than not, it is in a config subdirectory of source main resources. We provide configurations in this file for our project, as we've seen through key value pairs. However, we can set other properties that Spring Boot recognizes, not ones that we've made up. An example of this is server.port, server.servlet.context-path. Yes, that's right. We're changing the port for our embedded Tomcat server, and we're changing our application to have what we call a context root. So it's like a prefix that gets put in front of all our mappings for our controllers. They do not appear in the REST controllers. It's done for you through this configuration. So before, when we had localhost 8080/employee, to get hold of that REST controller now, it would have to be 8081, the context root work, and then employee. To prove that the values in the application properties file are actually going through the Spring environment object that represents a handle on the configuration for our running application, we can actually write this little bit of code I've got here, where I've actually injected in the Spring environment object, and I'm getting the property salutation. I'm getting a system property such as the Java runtime version. It's pretty unusual to do this. We have the @value annotation that we saw previously that we can inject in these properties using EL, and that would be the preferred way to do it. Now, YAML files, an alternative to application properties. It's a superset of JSON, and it makes clear the representations with respect to parent-child relationships between our properties. Spring will automatically support such files as an alternative approach to properties. On the left, you see our application properties with the properties that we have so far talked about, ones that we provided and ones where we overrode the defaults in Spring Boot. On the right, we see the application YAML equivalent. And we've added some more. You see the key value pairs are now in a hierarchical format. We don't have duplication of server or something like that. This makes it very clear. You must be careful in the indentation. It is 2 spaces indentation, and it is space between the colon and the value. EL is represented in both, and you can access one from the other to some degree. What actually happens here, the salutation is actually accessing the salutation property in the properties file. What happens if I have the same property in application properties and application YAML? Well, the answer is properties is king. It will override what you have in your YAML file. So what we're going to do now, we're going to do a small lab. Go to your lab instructions, make sure your Maven set up, and then I'll walk you through the lab once you've done that. So I'll see you on the other side. Welcome to lesson 5, request parameters, getting at parameter data. Here we will extract data from the HTTP requests coming into our REST controllers. We will return textual representations of server resources to our clients. Our resources are Java objects. They need to be transformed into text. For us, that will be JSON. And we will also have the ability to customize the response with respect to headers by responding with a response entity where we can add our own custom headers. So far, we have seen something like this with respect to extracting data from the request that's coming into a controller. I have a REST controller here with a single method get parameter. The request object's being injected in, and we're writing the Java code to get out the parameter employee. It's very long-winded, doesn't seem like a Spring way of doing it. The first way we can have Spring do the heavy lifting for us is to use something called URI templates, where the data is embedded in the URL. You see the placeholder here, example.org/foo/user ID. That's a placeholder. It doesn't have to be at the end. It could be anywhere in the URL. And below you see I've typed in the URL and I put bar. Bar is in the position of where that placeholder is. So it's considered that is accessible data that we could extract out of the URL. How would we do this? Well, we know that controllers, first of all, and REST controllers make use of dependency injection to delegate down to the root context. And that's what I have here in this employee controller with the employee DAO. The next thing, I have a request mapping of employee and a get mapping tied to, and then we have this placeholder. What we're saying here is that if you pass in a URL of employee / something, that something is in the placeholder position of the URL. We can extract that using the @path variable annotation. We give it a name ID because we may have more than one placeholder in our URL. We want the one called ID. I only have one here. So we extract that, pass it through converters, in this case to a long, and then we use that long to delegate down to the root context and the DAO to return an employee object. That employee object is then going to go through converters, pass into a textual representation of that object, i.e. JSON. So if I put in this URL, work as the context root, employee, controller, REST controller, and then 3 placeholder, I should get JSON Ross coming back in JSON format. In fact, it's being put into a response entity object, which might include headers and a status. And what you're actually looking at here is the payload. We're quite okay to do that unless you want to customize the response entity. That means we create our own. So here, I'm returning a response entity .ok. That's saying it's a 200 HTTP status code. I'm setting a custom header in this response entity builder that it's called. That comes out of the OK method of greeting, value hello world. And then the body is the payload from delegating down to the injected DAO. When you look at your response in modern browsers, you have DevTools. You can see my URL there, showing the status 200, and you can also see the custom header, greeting, hello world. And you see other headers that are generated by default, content type, it's application JSON coming back, and date. Now, perhaps different scenarios result in different status codes, and that is true. We have lots of different HTTP status codes. Here's an example where I receive the ID, I delegate down to my DAO, but I don't get an employee back because maybe the ID doesn't exist on the DAO or wherever the data is being sought for from that DAO. So instead of returning a response entity of OK, I can return a response entity.bad request. Since bad request doesn't have a body, you can see here what I mentioned before, response entity is a builder. You have to execute the build command in order to build the response entity, as I've done there. Why didn't I do that when we did the response entity OK? Because I used the body method and it does it automatically behind the scenes for you. The second means by which we can extract data is using a different annotation, request param. We can see here that I have a method no longer with a URI placeholder. It's just a straightforward path. Path is the default variable, so you don't always have to put it in. You might have seen me not put it in before. If it's the only attribute, it's considered the default. And you can see my request param. I'm looking for something called name.id. Where did that come from? Well, we can see the URL employee single !! ID equals 4. That's where it's coming from. And it will extract it out of the query string and place it into the long ID here. But with request params, they don't always have to be present. So here you see in the first code snippet a default value if you don't find that request parameter. And secondly, you're saying, well, we'll accept it if you don't find it. It's not always required. This is an old way of doing it. The more modern, if that's the right word, approach to do it is actually in the code snippet below, where we create a Java optional. And then with the optional, you would do a get, which would fall over if it wasn't there. More likely you would do an or else, and you could provide a default value there. So this endpoint, as we can now call it, this method in this REST controller can actually satisfy two URLs. When do you use a request param rather than a path variable? When it's optional. We talked about headers. We created custom ones when we did a response. What about sending headers to my service? How do I get hold of those? Well, three approaches here. The first approach is you injecting the entire request and get hold of the header by its identifier, user agent. Well, Spring likes to do stuff for us, so maybe we shouldn't really be doing that. It's very old-fashioned. So what about injecting in using @request header? Well, that's great. We can see we can get hold of it. It's a string. But what if we don't provide it? It's going to say I don't have that header. I'm going to be in trouble. So I'm looking at my last example here to say that the request header is optional. What about combining both approaches, path variables and request parameters? Here's an example where I'm returning a collection. It will return a JSON array of employee objects. Path variables are mandatory. They're part of the URL. I have to have them. Request parameters are optional. So you can see I have provided a path on my get mapping, which contains a placeholder for the path variable, mandatory. And then I put in an optional request parameter. And I'm using that optional request parameter to filter an existing collection coming back from an injected DAO. If it contains something optional, I will use it. Otherwise, I just say, does the last name contain something, anything really, an empty string. This means that again, we have a single endpoint that can satisfy two URLs. Work employee search Eric with a request param and without a request param. Okay, we have a couple of labs for you to do. One will follow on from the other, both using path variables and request parameters. Once you've completed the labs, I'll walk you through both of them. So I'll see you on the other side. So welcome to lesson 6, posting data and content negotiation. Here we will create REST controller endpoint where we can push data to it through an HTTP post. We'll also create Java clients to interact with our services. We'll be using something called REST template. We will then explore the principle of content negotiation, where your services can make decisions on how the textual representation of resources, i.e. Java objects, are to be returned, JSON or XML. And then we'll also look at a different type of client, very briefly, an AngularJS client that can be used to trigger your service endpoints and consume them in JavaScript. So far we have been using gets. It's time to do a post. If you look at the code snippet here, I have a post mapping saying that the method is tied to an HTTP post, and you'll see that I have a request body annotation for the argument. What's going to happen here, the textual payload of a request is going to be marshaled into an employee object, and that employee object will be injected into this method. Once it's injected in, it looks as if we're delegating down to a DAO to add the employee and generating a receipt object, which will be sent back as a response and rendered into text. The default's JSON, so I would guess it would be JSON. Now, we can dictate to a degree on what our service is tied to with respect to the type of data being posted to it. A service is unique by URL and the HTTP method name, but also we have these attributes produces and consumes, which can guarantee uniqueness of an endpoint. In this code snippet, I have both. The produces is what you think it is. What am I sending back? In this example, we are sending back either JSON or XML, but because JSON comes first in the list, we will favor JSON. As we'll see, the accept header on a request is being used to dictate which of these media types will be used with respect to rendering a response. If we don't send an accept header, it will take JSON because that's the first one. The consumes is to do with posting. It's for saying we favor JSON, but we'll also satisfy XML payloads being sent to us. That actually looks at the content type header that's being passed into the server on the initial request. We could have different methods for different media types. Here you can see we can list an array of the media types that we will accept. What if we send something that's not in our list? You'll get an exception, unacceptable media type. So here then we have a post. In this case, we will only accept JSON in and JSON out. If we send XML, we'll be out of luck. We'll get that exception. Let's say we're successful and the JSON is marshaled into an employee object. The question is, what do we return? When we post data, if we look at the REST specification by Roy Fielding, posts do not return data. We push data to the service. We will return, as we've got here, a response entity of accepted unless we throw an exception. In this situation, when I add the employee will be given an ID to say it's been successfully perhaps inserted on a database. If we don't get that ID, we're going to return a bad request by building a response. But if we do, we shouldn't return data. So how do we know this insert was good? Well, we return the accepted, but we also return a location header with a URL that identifies the URL you would have to go to in order to retrieve the data that was posted to the server resource. In this case, it looks as if it's just /ID. So the snippet below is showing you, hey, if you make a GET request to the URL that's returned in the location header, this is the service that you would go to with the ID that you got back in that URL to get the inserted employee. Okay, so we've got a little lab for you now to post data In this lab, you will just create the endpoint. We won't test it yet. And I'll walk you through the lab once you've completed it. So I'll see you on the other side. So now we've created some services, both retrieving data with HTTP GETs and posting data to push data to our service. We want to test these out with Java clients to simulate maybe one service calling another or your web application calling your services. But making remote calls are complicated. So Spring provides us a REST template class with an extensive API to abstract away the complexities of the remote call. The API is really based around HTTP methods. So for example, we have methods such as get for object, get for entity. The get for object is basically going to extract the payload out of the response. The get for entity is going to return you the entire response entity. And we also have post for entity for doing a post request. Any objects that are sent through a post on the REST template or retrieved through a get on the REST template will go through the same converters that our services have. So we could send an object converted into JSON and we get a response of JSON converted into an object. They always go against a running service. Let's take a look at the API. Here's the get for object. The parameters for this method are the URL, what you want to do with the payload when it comes back, i.e. marshal it into what? It's a class. Variable arguments of values for placeholders if your URL has placeholders in it, which would be used, for example, for path variables. So here I have my new REST template, get for object to this URL. You want the response converted into a Java string, and you have a placeholder. So positionally, it's going to align itself. So 1 will be put into the first placeholder. It just happens to be 1. This is the service it's going against. The path variable is used, delegates to the DAO. If we don't get 1, we'll send back a bad request. If we do get 1, we'll send back a 200. And in the body, we will send back an employee in this response entity. The REST template receives that response entity. By this time, the employee object has already been converted on the server side into JSON. So it'll take the JSON and convert it into a Java string. And that's what you see here. The get for entity, once again, a get. The response is basically converted into a response entity at the REST template end. This means we have the ability to get hold of the status code and maybe header information. The parameters for the method are the URL, what you want to do with any payload in the response entity in terms of marshalling it into what, and once again for URI templates, var args. So here's my URL. We're going against a template. We're getting for an entity against that URL. The payload is to be parsed back into a Java string, and we have one URL placeholder, which we're going to put 1 in. This returns a response entity. We said that we wanted to create the response entity from the response at the template end as a response entity with a string payload. So note the generic. We can now get hold of the status code and we can get hold of the body. We're going against the same service as before. We can see the result there, getting the status code. The third method we could do is exchange. It doesn't have a get in front of it. You have to stipulate what HTTP method you're using. It does return a response entity. The parameters are the URL. You have to stipulate the HTTP method. An entity, be it headers and body or just headers that we wish to write to the request. So this would be like if we were posting something It can be null if you're not sending anything. What you want to do with the response when it comes back with respect to its payload, and if you have a URI template, you have the placeholders in the URL, so there'd be var args of the values you want to put into the placeholders. So here's my code. Note, I'm creating some headers. I'm creating an accept header of JSON to say I would like JSON back from the service I'm about to call. So we're creating these headers, and we're creating an entity that just contains headers. We then use the REST template exchange method to the URL. We're doing a get. We're passing in an HTTP entity, which is just headers. The response payload will be converted into a string. And we have var args. We just have one because the URL is templated. With this approach, we can get the status code, we can get the body, and we can get the headers, and you can see them there. Looks like we did get JSON back because that's what we asked for with our accept header. If you didn't want to send an entity with any headers in, you could just put null in the third argument of the exchange method. Our next example is a little bit different. We're doing an exchange to a URL. We're not sending an entity. We do have a templated URL with a query parameter there, so we're using var args, but look, we've got an employee class, not string class, and our response entity is of a generic type of employee. We're marshalling the response that's coming back, which is JSON, because we saw the content type was JSON before, and we're marshalling it directly, not into a Java string this time, but directly into a Java object, an employee object. Here's a JUnit test. We're just doing a negative test to show you going against the same service, same URL with a request parameter. And we're asking for an employee. 99 is its ID. So we're going to pretend that 99 doesn't exist on the server side when we go against the DAO. So we should be getting a bad request back, and that's what we're asserting. Now, when we return collections of data, more than one object, we have the opportunity, one, of just returning it into a string and parsing it with the Java API for JSON parsing. But again, that's not the Spring way. Let Spring do the work for you. So we have this parameters type reference, which has a generic dictating of what the parameters type reference will be. You'll notice it's empty because I'm creating an instance of an interface. It has a series of default methods in it. I'm just using this to give it the generic of what I want. The generic is a collection of employees. I'm using exchange, you have to with this, the URL, a get, I'm not passing in an entity, and my parameters type reference is deciding what to do with the response payload when it comes back. By taking this approach, it will take the JSON, build a collection of employees from the JSON, and populate employee objects to insert into that new collection. So I'm asserting the status code was okay, and I'm iterating over the body of the response entity, which is now a collection of employees. That's the service I'm going to. I can see the toString method being executed in my system out print line. I've successfully got those objects out. Posting data. I've created a new employee. No longer using get for entity, I'm using post for entity. I've got my URL and I've got my new entity. My entity is my employee object. I'm wrapping it. I'm posting it. You're going to get a response back. What do you want to do with that response? Whatever comes back, I'm saying to use the default type approach, which is to say it's going to be of a string. I'm then saying, response entity, you have some headers. Get me the location header. Get me the first location headers. HTTP headers do not have to be unique. Potentially, I could pass back lots of location headers, but that would be kind of crazy, but it's possible. And look what I'm doing now. I'm doing a get for entity with the URL that I got back from the posting to go back and actually get the employee that I inserted and marshal it directly into an employee class. This is the service I'm going against. You're seeing exactly how we would interact with the service to push new data to it and to verify that that data was indeed received and processed by using the location header. We can do this with Exchange. Same scenario, using the Exchange method, using the HTTP post, passing in an entity, wrapping my employee, executing it, getting the headers, the location header out, going back to the service, using the URL from the location header to get the inserted employee. Just another approach to doing it. Okay, so we are going to break for a lab. You have your lab instructions for the lab. Make sure your Maven's set up too. Always check that. Follow the instructions. I'll walk you through the lab once you've completed it. We're going to interact with our services by using REST template. I'll see you on the other side. So now we're going to talk about something called content negotiation. I'm sending requests to my services and I'm getting textual responses back. How can I dictate what format that response will be in? JSON, XML, or something else? Generally, Java classes can be rendered into either JSON or XML. And the clients may well be expecting a specific representation when it comes back. For example, you're calling it with the REST template. You've decided not to marshal it into a Java object. You're marshaling it into a string. And you're taking that string and creating a JSON node, and you're manually looking inside that JSON. You're expecting it to be JSON, but if you got XML, you got a problem. So we have to ask for the representation that we want, and that is called content negotiation from the client to the service. The selection of the best representation is made by an algorithm on the server called server-side negotiation. If that selection is made at the client side, it's called agent-driven content negotiation. What we're saying there is that the server may make the decision, or it may make the decision based off a request coming in. We use the accept header. If an accept header is provided, we will make the negotiation using the content type within the accept header. If one is not, it'll be dictated by the algorithm on the server side. By default, the service returns by what it can find on its class path. It'll be JSON. When an accept header is provided, it will utilize that. Here you see my produces in my service endpoint saying I will accept JSON or XML as a means of sending what effectively is my employee object back. My client is passing in an accept header, and it has to match one of these MIME types in order to access the service. In order to return XML, for example, we use something called JAX-B. JAX-B is a framework for marshalling XML from and into Java objects. You must have an XML root element because XML has to be well formed with an outer wrapping element, and that's what that XML root element says. So I've annotated employee there. Now here I'm using a little tool in DevTools, I think in Chrome, and I'm passing in my URL on a GET request. I'm actually going, I think, against this service endpoint here, which says it'll accept JSON or XML. So here I'm saying, please provide me JSON because I'm sending the accept header with application JSON. When I execute it, I get a 200 and I get JSON back. On the right-hand side of your screen, we see the same tests, but sending application XML. Because employee has the XML root element, I'm able to return a 200, and you can see the XML that's being passed back. What if I send two? I'm sending application XML and application JSON in my header. I'll accept either, the client is saying. Well, we have to go and look at our service and say, do you accept these media types? It actually accepts both, so a decision has to be made. It takes the first media type in the accept header, in this case XML, matches it against the acceptable media types on the service. And we find XML in that list. If it doesn't, it will then go to the second one, JSON, and go through the media types on the service side to find JSON. If it still doesn't find it, we will get an HTTP 406 response code saying, hey, the media type you sent in the accept header could not be found as an acceptable media type on the service. So here XML is the first in my client list. We do accept XML, we get XML back. If I switch them around and made application JSON, application XML, we will get JSON back. So order matters. Sometimes it can go wrong, not because we've sent a media type through on our accept header that we don't accept. We are sending a request in and we've decided to say we want XML back. Now this service is returning a collection of employee objects. There's a problem here. If we look at the Java docs, we will see that ArrayList, for example, is not annotated with @XML root element. This will fail because there is no indication of what the wrapping root element will be. So this getAll method here in this service for this get mapping should only have a media type of JSON because JSON wraps a collection in a JSON outer node, if you like, of a array. If you really wanted XML, you could create a class to wrap your collection of employees. I've called it employee collection. It's your class. You can annotate it with XML root element. You'll have to have your service now return that wrapping class. Looks like we create a new instance of it, go down to the DAO, get the employees and inject it in through a setter. And we send back an employee collection object and you can see the XML there. But this is now a different endpoint for the same URL. What I mean by that is, for JSON, you could just return a collection of employee objects and then have a separate method for XML Same URL, which just returns an employee collection object that wraps them. So we're now starting to see that in the REST spec, a resource is identified by URL, HTTP method, and what it produces. We can customize our XML. I've given the reference to the JAXB specification there. If you wanted to decouple your XML response from the actual structure of your Java object, or you wanted to customize what the collection was called, there's various JAXB annotations. I've used a couple here to wrap the collection of employee objects, which I now call members, in a staff node beneath the root element, which is the name of the class itself. Because I annotated with XML root element, I could have put name equals foo as an attribute of XML root element, and the outer XML node would have been foo. So now we'll talk about content negotiation from the perspective of REST template. The code in the orange box is basically creating an accept header to say I want XML back. I'm creating a REST template using the exchange method against a URL to get. I'm wrapping the headers in an HTTP entity. If there's a payload coming back, I want it marshaled into a string. And my var args will match up with the placeholders in the template. So I've sent I want XML. Is XML an acceptable media type? It may not be the first in the list, but it is an acceptable media type. I will get XML back. The same test, but sending an accept header of JSON. It's an acceptable media type. I will get JSON back. The same test again, but sending an accept header to say I'll accept either JSON or XML. Notice I can't use the enum. I've used the actual values of the enums in a comma eliminated list. It hits the service and says, okay, is JSON acceptable media type? It's the one I prefer. It's the first in my client list. Yes, it is. You get JSON back. If you do not send an accept header, the default will be JSON because of the class path of a Spring Boot project. That's the default. Okay, so if we're posting data, we would go against a service like you see at the bottom of your slide, where we have the request body of an employee object. The service is annotated with a post mapping. It's tied to the post, of course, and has a consumes attribute. It's saying it will consume either JSON or XML and marshal it into an employee object. Now, if we look at the client code, I probably didn't need to provide an accept header, but it's giving you an example how you can create multiple headers. Both the accept header and the new one, the content type. The content type is dictating what the payload is you're sending to the service, and it is that content type header the service uses to match up against its consumes attribute list of media types. We do a post for entity. We hit the service. The service says, okay, we got a content type of JSON. Is that one of my acceptable consumes media types? It is. I'm good to go. And I can fall into this controller method. Okay, we have a couple of small labs, which I'd like you to go through. We will interact with our services once again using content negotiation. That's in lab 6.3. And in 6.4, follow the instructions to bring into play an AngularJS application client. It's a separate project which will access the same services you're accessing with REST template. To give you an example of a different client interacting with your services. I'll let you go through the lab and then we'll walk through it together. So I'll see you on the other side. So welcome to lesson number 7, rendering a view. So we will be defining a controller, not a REST controller. Return types from controllers are interpreted as destinations, and they're done that by triggering a view resolver based off whatever's on your class path in order to locate a view, be it HTML, JSP, or whatever it may be. And in our case, we will be rendering an HTML5 view, and we'll be sending data through to that view from our controller via the dispatcher servlet and the request. Spring MVC is a web framework that uses both controller and REST controller beans to handle requests. A request comes into the dispatcher servlet. It is mapped to a REST controller or a controller through handler mappings. The dispatcher servlet uses the handler adapters to invoke the methods that the URLs are mapped to in the controllers. It will convert parameters going in and responses going out. There'll be an exception resolver in case something goes wrong. Return types from controllers are passed to the dispatcher servlet. They are considered not to be written directly to the response object as we did with REST controllers. They are to be considered as a view and passed to a view resolver who will identify the view for the dispatcher servlet to dispatch to. Although we can inject the request in, set an attribute in the request, and return a string, we're very coupled passing in the whole request object. The return string here is going to be passed to the dispatcher servlet onto the view resolver, and the view resolver, because of our dependencies using Thymeleaf, will say it's in templates home.html. A different framework for view templates would look in a different location based off your POM dependencies. This approach also couples us to the fact that we're just using HTTP, which we probably are for most of the time. So Spring provides an alternative just in case you move to a different protocol in the future called the model. It's a glorified map the dispatcher servlet always creates before delegating to a controller method, which means it's available for you to inject into your methods in your controller. Here's my get mapping, my get all, and my model is injected in. I don't need an annotation for this. It knows what model is. It's part of the web application context. Again, we return home, so that's going to be our destination. But instead of dealing with the request directly, we're dealing with the model and we're putting in an attribute employees. So what's going to happen with this model? Well, the dispatcher servlet has a reference to it, of course. It knows where it is. It can get hold of it. It takes the state of the model and puts it in the HTTP requests, takes the home string that we returned, passes it to the view resolver. It says we need to go to templates home HTML. And since we've now populated the request, it does a server-side forward with that request object to the view, and then it will render the view and return that to the client. So the request is available in the view, and therefore the data we put in the model that went to the request is available in the view. Where's the view? Remember our dependencies in our POM. We returned home. Looks under source main resources, looks under templates. There is our home HTML. That's where we're going to go. And in our home HTML, when we start to reference JavaScript or cascading style sheet, it's going to look in static. And underneath static, there will be the images, CSS, JavaScript files. Frequently, you make subdirectories of CSS, JavaScript, and images, but it's under static. Now, we saw how we injected in the model, and we set an attribute in it. There is a convenience class called a model in view that you can return from your controller methods. As the name somewhat gives away, it has a means to add state into it as key value pairs. So I'm adding an object, employees get all, and I could add another one. And it also enables me to set a view name. This then is returned to the dispatcher servlet, and the dispatcher servlet says, I know what to do with the model in view. I need to take the view name out and give it to the view resolver. I need to take the objects out and take those and put them in the request. If you're just dealing with one object, much like I'm doing here, that you want to put into the model and hence the request, you can use the convenience constructor of model in view, which is the view name, and then the single key value pair that is going to be the state of that convenience class. You could also inject the model in as well if you really wanted and add things directly into the model. The dispatcher servlet's really clever. It can say, I've got a model with state in, I've got a model in view being returned. No problem, I can deal with that. I can populate the request. And I know where to go because I'm going to hand this off to the view resolver. Once the dispatcher receives, this is the view I want to go to, the request has been populated, we can then render the view and give a response back to the client. So if we go back here, we can see that I was sending back state in the form of a key value pair of employees from an injected DAO that was placed in the request by the dispatcher servlet. You can see employees in this HTML5 snippet, get each employee and display its first name and last name. And you can see on my right, you can see that the state is now being displayed on the view, because it's available in that page. Okay, we're going to do a very small final lab here where we're going to get you to use a controller method to render a view. We've kept this side of the course pretty small because primarily Spring Boot is used for RESTful services, but this does give you an idea that you could create a web application within Spring Boot and not necessarily rely on something else consuming your RESTful services, as we saw with our Angular front end previously. So I'll let you follow the instructions. Make sure your lab's set up for Maven okay, and we'll then walk through it, and I'll see you on the other side. So welcome to our Spring Data Repositories course. I'm your instructor, Derek Parsons. Looks like I'm having a long cool drink there after a long hike. In this course we have two modules consisting of one or more lessons. Our first module, we will cover Spring and its interaction with Java Persistence Architecture, or JPA. We'll also talk about Spring repositories from the Spring Data project and how it abstracts interaction with databases through JPA away from you to make it really easy. The second module, our 2 lessons here, are to do with aspect-oriented programming. We'll talk about advices and how we can proxy beans for non-evasive cross-cutting concerns logic such as logging. And this actually forms the basis for our second lesson, which is to do with Spring's transaction management approach. Welcome to our first lesson, Spring and JPA. Here we will get an understanding of what a persistence framework like Hibernate is and how it can be used with JPA to abstract away its complexities and then abstract those complexities of JPA away with Spring. So we'll explore the basics of integrating these frameworks into one Spring application. We'll inject key JPA classes into our Spring Managed Beans so we can delegate to them and in turn talk to a database. The Spring framework provides extensive support for working with SQL databases. We can use JDBC, Java Database Connectivity with JDC template, or we can use complete ORM or object relational mapping technologies such as Hibernate. We generally develop with in-memory embedded databases, so we don't have to talk to an external database which is outside of our control. That's for production running. Spring Boot can auto-configure embedded H2, HSQL, and Derby databases. You don't need to provide any connection URLs for such databases. Just put the relevant dependency in your POM XML of your Maven project. Spring provides an excellent abstraction of JPA. JPA is a specification, not an implementation. There's a set of interfaces interacting with a variety of different object relational mapping frameworks. JPA abstracts away the specifics of an ORM framework such as Hibernate. So instead of dealing with Hibernate classes such as Session or Session Factory, we use JPA interfaces like Entity Manager and Entity Manager Factory. So Hibernate is an implementation of JPA. If we want to deal with an external database, we can go to our application properties of our Spring Boot project and put in the relevant URL and connection properties to connect to it. We must, of course, have the appropriate POM entry as well to interact to that database with the appropriate driver. Some of our databases use the concept of connection pooling. When we connect on an on-demand approach, we open up a connection for each request and close it at the end of its use. This can lead to overloading. Subsequently, to solve this issue, database connection pooling can be used, which will also increase performance. These connection pools maintain multiple of pre-created, eagerly created connections with the database. When demand is high, you basically take one out of the pool, use it, and put it back in the pool. And we will create a number of them so we can satisfy multiple requests at once. While working with Spring Boot Starter JDBC, Spring Boot will by default use a Tomcat JDBC connection pool. To use a connection pool such as Database Connection Pooling or DBCP2, we need to remove this dependency and add the appropriate DBCP2 dependency, as in your notes. So now we can amend our data source configuration to make use of pooling. Basically, if it's configurable, we can put it in our application properties file. When we use an embedded database, we need a quick way to get off the ground. We have the appropriate dependency in the POM. There's no connection URLs in the properties file. We would like to populate that database and there are two key files, schema SQL to define the tables and data SQL to insert data into those tables. If we are using Hibernate under JPA, we have to stop the auto creation of a database schema, i.e. the tables, from the JPA entities within our application. These are classes annotated with the appropriate JPA annotations. So you can see the single property you need to put in your application properties to stop that happening. So on application startup, because we have on the class path schema and data SQL, Spring Boot knows, aha, I need to create and populate tables within a database. When we interact with a database using a provider of JPA, we will come across a problem. This problem is called lazy loading. What happens here is that when you get an object and it has a dependency on, say, a collection of other objects, Hibernate will bring back the first object, but put in the place of the dependency of the collection of these other objects associated with it, a proxy. This is to bring back just the data you need when you need it, rather than eagerly bringing back all the data where you may never go down to the collection of entities. You will always work at the top level or the parent object. When we retrieve lazy loaded data, we have to have a connection or session, as they call it in Hibernate, open. What happens when we retrieve an initial entity with lazy loading of its collection of dependencies, collections of entities that are a dependency, is that when we retrieve that first entity, a transaction is closed within the scope of the Hibernate session, which means when you delegate down to the proxy, it will attempt to go to the database but says, aha, there is no open session. So there's two approaches here. You could eagerly bring back everything, or we have this workaround. Just by placing the property you see at the base of your screen, you are saying whenever you delegate down to that proxy from your parent entity, so to speak, it will open a temporary session and run the appropriate query to go and retrieve your data from the database. So let's take a brief look at the JPA architecture. Very quickly, we have a persistence XML, which configures an entity manager factory. This factory class has all the database details. It has a persistence class to load it. We call it bootstrapping. The entity manager factory creates entity managers, which manage a persistence context of entities. Those entities have mappings to map properties to database schemas in the form of columns in tables. You talk to the API of the entity manager to interact with the database. Spring shields us from all of this. The entity manager instance is created from an entity manager factory. All the connection database information is in the entity manager factory. It manages a set of entities in a persistence context where they are cached. They're cached because every entity has a primary identifier, and if you request that entity by a primary identifier, it checks the cache to see if it's retrieved it from the database already. If it has, we don't need to go to the database again. The Entity Manager Factory instantiates transactionally scoped Entity Manager instances. Spring Boot provides us classes for injecting JPA persistent units or entity managers into our Spring Managed Beans. There is a template class called JPA template. We will not cover it here. It's considered bad practice. We use the JPA classes and inject them into our Spring Managed beans, not the template. Entities are annotated with illustrative mappings between a Java class and its properties to a database schema. Here's an entity. So it has to be annotated with that entity because we scan for these classes to say these are the classes that make up our persistence context. If the table doesn't match the class name, we'd have to put @table in there. As I mentioned, every entity has a primary identifier with that ID. What column in the database does the ID map to? In this case, it's EMP-ID. And who's responsible for generating the value of this ID? In this case, we're saying there's a generated value from the database. Every cached entity in the persistence context has a primary identifier and it is unique within that cache. We also have column annotations above properties to say this property maps to this column on the table that this entity is mapped to. It's best to always put it in because certain databases, when it comes to mappings, may object to camel case notation, so you might get first underscore name being the column that it thinks it's supposed to go to. So put them in. We must have a default constructor because the framework will be creating instances of this. And when a query, for example, is executed, a result set comes back, every row in the result set will need a bean to marshal into. So we have to create those beans and we use a default constructor for that. So here I have a plain old DAO POJO. I've injected in the persistence context. I'm delegating down to that with its API find, in this case employee class. And with its primary identifier, what's happening here, it's delegating down to Hibernate. Hibernate is generating some JPQL. That JPQL is being converted to SQL and being passed to a JDBC connection, which then interacts with the database. So a lot is abstracted away from you. Entity managers are transactionally scoped. So when it commits, that's the end of that entity manager. You'll need a new one when you interrupt the database again, but that's okay. It's just injected in. We may look like we're reusing it, but we're not. If you want an extended context beyond one transaction commit, you'll need to inject in the entity manager factory and create. And once you've created the entity manager, it's up to you to interact with it and then close it. So when we interact with the database, we're at the mercy of its local transaction manager. So every interaction will work within a single interaction of the database with a single transaction. So if we want to extend that, so we have a method that has maybe 3 or 4 interactions with the database in it, we would mark it with @transactional. So here I've got add, update, and delete. Here I've got an implementation of that interface. So I'm doing a find, doing an add. Let's take a look at the add. We're persisting an employee class. What's happening here is that this method is running in a transaction. The default propagation attribute for transactional is required. So if one is provided, it'll use it. If one isn't, it will generate one on its own. When we interact with the database, we flush, i.e. we execute under the hood some SQL to insert the employee. Then we commit the transaction. When we interact with that flush, we're actually going to populate the ID that was generated by the database into the ID of the entity that we're trying to push into the database through SQL. So I can return the ID here. We have an update, again runs within an entity manager factory. Entity manager, it's transactional. We find an employee, it's in the cache. We play around with it. We then finish the method. When you finish the method, you flush the context of the database, JPQL to SQL to JDBC, and then you commit the transaction. Same with the delete. Find it, remove it, commit the transaction. We can create queries from employee. That is going to be JPQL. It's saying get me all instances of the employee class from the class employee. Basically, it's looking at the table annotation to do a select all from the table that the employee entity is mapped to. Create a query from employee where dept, get everything from the table that the employee entity is mapped to, where its dept property is equal to whatever you pass in. This is a positional price parameter, index from 0. We do not use this, but the important thing is dept has a column annotation that it is mapped to, so under the hood eventually will generate select all from the table employee, where whatever the column dept is mapped to is equal to the argument that you pass in. So the result set comes back, and the results set populates a collection of employee objects. Each row in the results set is marshaled into its own employee instance. We have a third example here where we're using name parameters. This is what you should use. Again, it's JPQL, not SQL. Note the :name, :department. We're setting the parameters, executing the results list. We bring back the results set. It's mapped to properties and a class, populates the collection of employees, and that is what is returned. There's this thing called type query. Basically, it does a little bit of typing. So we can return a more specific result. The main advantage from this, since it's a type query, we can stipulate polymorphic queries. So maybe we're going against a table and that table is mapped through JPA, which you can look up to a hierarchy of employee objects, maybe a local employee or a remote employee, but they can all come back and populate the collection of employees. We have this thing called name queries. The name query again, create a name query. This is JPQL. In the annotation name query, we just trigger it by name in the code beneath, set the parameter, execute the results. So what we're going to do now, we're going to break. You've got 3 labs in your instructions. I'll walk you through the solution once you've done the labs one by one to get your hands dirty with JPA under the control of Spring. I'll see you on the other side. So this is our second lesson, Spring Repositories. Here we will abstract away the JPA Entity Manager through a proxy mechanism of some key interfaces to simplify your interaction with the database in your code. We'll interact with a Spring repository for create, read, update, delete, CRUD operations. We will expose the repository through the Spring Data REST project as a RESTful service in its own right. The objective here is to make interaction with the database very simple. The Spring Data Commons project provides the repository abstraction. It wraps an entity manager, provides an interface for JPA-based access to a database through a series of interfaces. The first one is repository, and we have specialized sub-interfaces of it: CRUD repository for CRUD operations, paging and sorting repository for pagination, JPA repository, JPA-friendly methods. You will interact with the methods of these interfaces. How? Well, you create an interface that extends a Spring Data interface. Here we have employee repository extends JPA repository. The generic is indicating this is tied to the entity employee. The long, the type of the employee entity's primary identifier, its ID for the cache. At application context time, Spring Boot recognizes these interfaces, generates a proxy implementation of your interface. This will mean it will effectively provide implementations for the methods within JPA repository and any super interfaces above it. So we know the employee is an entity, primary identifiers are long, we need an entity manager, we generate a proxy implementing the key interfaces. The methods we will implement will be from JPA repository and, as I said, interfaces that it extends. For example, we have an employee get one long method in JPA repository because of the generics we're using. It returns an entity with a given identifier. My class path has Spring data on it. I can generate an entity manager and I need to inject it somewhere. In this case, it's going to be the proxy implementation using @persistence contacts. Once injected, the implementation of this method in your proxy conceptually is something as you see here. Just delegate down to it. I know the employee class is my entity and I know the identifier is a long. We can provide, in addition to implementations of the methods provided by these key interfaces, our own abstract methods that the proxy will provide implementations for. The naming convention is very important here. Prefix by find by, it means this is a query and it's going to generate a select. It's going to select against the entity of the repository, and then you see first name in my example here. That's a property of the employee entity. So conceptually, we'll generate a query, get employee from employee, where employee.firstname equals the argument of the method. And then we will execute a result list against the query, which delegates down to the injected entity manager. In fact, it uses something called the JPA criteria API behind the scenes to enable all of this. Let's take a look at some examples here. Find by last name and first name. You can see the JPQL. You can get the idea that we're selecting everything from employee whose last name and first name are equivalent to method arguments. Find by last name or first name. You can see the or coming in there that will be part of the selection. We can use between, we can use less than, we can use greater than, is null, not null, we can use likes, and so on and so on. The key thing here is the find by prefix and then property and then some sort of concatenation in terms of a or, like, and in order to generate the appropriate query. So, how would we use our repository? You would inject it into your Spring Managed Beans. Here we have the injected repository. In fact, we don't. It's actually the proxy implementation of the repository. And then in the R methods in this Spring Managed Bean, we're just delegating down to it with the appropriate method that the proxy is implemented. Find all, find by ID from CRUD repository, or maybe find by last name like. Maybe you implemented that abstract method in your repository. You just delegate down to it. An extension of CRUD repository provides for paging and sorting. We can now have a find all method overloading the traditional find all method by taking a pageable. This pageable object can contain properties used to specify page size, the current page number, and what you're going to sort by. So here we have an employee repository, extends paging and sorting repository. Once again, the generics dictating the entity and the primary identifier type. And you can see some code here where I've created a page request object. 0 means I want the first page. 5, there are 5 entries on each page. And I'm going to sort by det. Det is a property in the entity that is part of the collection of the items within each page. And we just use it in the find all. If we just do pageable next, we will literally get the next 5 records on page 1. I've injected in my repository. Once again, I'm just using its API. Find by ID. This actually returns an optional in the implementation of this interface. So if you don't find something, you can do an or else. That's like a default value. We have a save method for adding. We can find by ID again. We can find by ID and then use the repository delete method. So we have CRUD operations available to us. Which repository should you extend? To help you out, you might want to consider this. CRUD repository find by ID returns an optional. So we can use the get if the object exists, but that's a blocking call until something gets put into the optional. Or else get or else if we're not sure. Either or else get actually executes a lambda, or else returns a default value. But we have JPA repository that has get1. That returns an entity without the optional. If it doesn't find it, it will throw the appropriate entity not found exception. JPA repository also has a series of other methods specific to JPA, such as flushing the persistence context. Flushing means I execute some XQL behind the scenes eventually to synchronize with the database, but not necessarily to do a transactional commit. That usually comes after a flush. Execute the SQL, commit or rollback. Well, we saw the find by queries. We may have also seen name query and domain classes, but that couples your entities to queries. We would like to define query methods in our repositories, selecting any name for the method, not just find by. So here you see the @query annotation with JPQL. That's selecting objects and properties which will eventually be transformed into SQL tables and columns. And you can see my query is above an abstract method in my interface with @param. @param is syncing up through named parameters to where the parameter in the method argument should be placed in the resulting query. We also actually have a means to do the same with native queries that uses SQL. We can also execute bulk updates as long as you're in a transaction. One approach is to use 2 new annotations. Transactional on the repository method, the abstract method annotated with that query, and then put @modifying above it. This will identify a select for update query. So now we have a couple of labs for you to use string repositories. You have lab instructions. Once you've done the lab, I'll walk you through the solution. So I'll see you on the other side. So now that we've coded up our repositories, we're now going to try and expose them as a RESTful service in their own right, so that HTTP can access them directly. With minimal code, one can create a RESTful representation of our JPA entities that follow what we call the hypermedia as the engine of application state, or HATOAS principle. What this is that a REST client enters a REST application through a simple fixed URL. It gets a response back, and in that response are embedded actions that the client may take within the resource representation that it has received. These often manifest themselves as URLs, where you can go to other endpoints exposed via Spring Data REST with respect to our repository. The resources, therefore, are implemented in a hypermedia style. It uses a media type called HAL-JSON because of the HATOAS principle that it follows. The media type is actually application/HAL plus JSON. To get us started, we simply add the Maven POM dependency for Spring Boot Starter Data REST. We annotate our repository to expose it as a REST service once we have that dependency. Behind the scene, we know a proxy is being implemented of this interface with respect to its methods and any methods it inherits, say, from JPA repository. Those proxy methods are now going to be annotated with Spring Boot's REST controller annotation, request mapping, get mapping, post mapping, all the things you can see in our Spring MVC and REST controllers course. The key annotation here is repository REST resource. That does it. We have two key attributes, collection resource rel and path. Well, the collection resource rel is indicating what do you want the name of the element to be that wraps a JSON array that represent a collection of resources being returned from the REST service. The path. What path within your Spring Boot application is this entire RESTful service for this repository behind? When you start your application up in Spring Boot, the repository has been exposed. There are multiple URLs that you can use to interact with your repository. These are the proxy implementations, which are now being exposed through RESTful endpoints. So for example, we have here, let's say my context root is HR, we can see employees is going to bring back representations of all employee entities using what we call the find all method, which we have seen in the repositories already. You can see that the employees is taken from the path attribute. Now, as I mentioned, HATOAS, hypermedia as the engine of application state, is the principle we follow here. So what does that look like? When you perform RESTful requests, we only get the data that we need and not any actions around it in normal circumstances. We would get all the data for all the employees, if you like. With a HATOAS request, we get the data and any subsequent actions to go and get more data, like other services. What you're looking at on the right is rendered HAL-JSON. You can see the collection resource rel being the parent node, so to speak, that wraps our collection first name and last name dept is coming from the employee entity. And then you see the actions, they manifest themselves as links. They look the same at the moment, but we have to change that. But we can see they contain URLs, actions to other endpoints that a client that receives this JSON can trigger to go back to the service to those particular endpoints. We are trying to do loose coupling here. If the consumer of a REST service needs to know all the URLs of your repository, we're very tightly coupled. If we just expose a collection of those URLs and we provide the others in HATOAS links, then we are achieving a less coupled implementation model. What about queries? They actually go under the path/search. And here you can see the URLs that are being generated. The find bys first. We know what that means. It means a query for select. Find by first name, and dept greater than, find by dept. We can see here that the URLs are very explanatory on what the query is going to be. And then change department and get employees. They're probably methods annotated with our @query because they don't start with find by. You can see the funny looking question marks here. These are placeholders, named placeholders in your URL that when you click on them, you would have to replace that with whatever department you wanted to put in there. Paging. You can see the pagination, page, size, sort. And as I mentioned about the URI template previously, now you can see an example how the URL you would type in to trigger that service is saying, well, there's a query string for page, size, sort. So it looks like we're going to the first page, and at the base of this HAL JSON that's returned, you'll see what page you're on, the number of elements in the page. We said 4, the total elements in the collection, the total number of pages. What if we just change the page to 1? Looks like we've gone to the next page. We have something called the HAL Explorer. This little web add-on, if you like, to provide a very convenient front end to browse your HAL JSON. You can point it at any Spring Data REST API and navigate around the HAL JSON. Remember, HAL JSON has actions in it that you can trigger to go to other services. With the appropriate dependency, if you just type in the context root, localhost 8080 HR we used before, not the path this time, you will be redirected to the URL you see there, which will be your HAL Explorer. So here we are in the Explorer. We were redirected to this URL by typing in my case, localhost 8080 to this URL. On the right hand side, you're going to see response status, headers, and body. This will be raw JSON. On the left hand side, there's a little GUI. So let's use this. We see a templated URL there. So I'll fill this in. 0, let's 3, dept. And you can see the expanded URL there. Hit go. Looks like we've got raw JSON on the right. We have students that we can click on here. We have 3 students on each page for a total of 8. We're on page 0. Now, let's go to the search department, one of our finders, I think. Oh, actually, it's a query, get by department. Let's type in chemistry. Who's in the chemistry department? Looks like Eric and Anne are in the chemistry department. Again, you can see here the URLs, and we'll talk about how some of the different URLs are starting to appear in my example here as we go through subsequent sections. Hello, this is lesson 3, aspect-oriented programming. Here you'll be able to describe aspects, join points, point cuts, and weaving. You'll be able to configure advices via Aspect-J annotations. You'll be able to describe the difference between core concerns and cross-cutting concerns in an application. The goals of AOP are simple. Increase modularity by allowing the separation of cross-cutting concerns from the core concerns of your application. So let's define those. Core concerns are your business logic, calculations, getting data, presentation logic. Interweave with that logic will be cross-cutting concern logic. Logging, transaction management, security. It often clouds the code because so much code is taken up by doing these types of concerns. So we want a way of applying these cross-cutting concerns, not in a scattered form as they are at the moment, coded in multiple business means, but in a central place. We want the ability to apply these concerns or unwire those concerns. So we may want to have logging, we may want to turn logging off, we may want to have security, we may want to have transactions, we may want to turn transactions off. Spring AOP is proxy based. Basically, a proxy looks and acts like the real thing, performs services on behalf of its client, and delegates those to a target object or real object. It may add functionality prior to that delegation or after it comes back from that delegation. In some cases, the proxy may actually perform the service itself and not even delegate down. Security is an example of a blocking proxy. The proxy pattern therefore involves the creation of a stub or surrogate object. The proxy accepts invocations from the client and delegates to the real object, which does the business logic. The client thinks it's working with the real thing, but it's not. It's working with the proxy. So how does it look like the real thing? It will implement, for example, the same interface as the real thing. So it's going to have exactly the same API. AOP components complements object-oriented programming in that there are distinct roles within the AOP framework, so to speak. There is an aspect or aspects where the cross-cutting concern logic will be found. It's actually found in methods that we call advices. There is a join point, which is basically where you can join into the application. In our case, it's method execution. There's a point cut, which basically associates the join point with an advice. The advice itself, which I've mentioned, which is where the actual cross-cutting concern code will be. And there's something called weaving, which can be done at runtime or compile time. The compile time approach is done by a framework called Aspect-J, where it will actually recompile the class to insert the code into the bytecode of the class itself. We do not do that. We use Spring AOP, which is proxy-based at runtime. Aspects can be used as an alternative to existing technologies like enterprise Java Beans for remote communication, transaction management, security, profiling, and logging. Spring AOP is actually built on AOP interfaces called interceptors. Everything is Java. You do not need to learn a specialized language to do AOP. Objects created in the Spring IOC container are unaware that they've been proxied and therefore advised. That proxying approach is dependent upon configurations. Spring AOP also has built-in aspects, often called advisors, for providing transaction management, performance monitoring, and security. Spring AOP is also based off a framework called AspectJ. Spring AOP, you could say, is a subset of AspectJ, but AspectJ is compile time weaving. It compiles the new class files and the advice is injected into the bytecode. Spring AOP is proxy-based, and the proxy surrounds the whole invocation of the advice. Aspects can be defined using Spring configuration classes with key annotations. That's what we will follow. In order for this proxying mechanism to execute, you need an enable AspectJ auto proxy on a Spring configuration class. In Spring Boot, you just need to add the Spring Boot Starter AOP dependency in your Maven POM. So when a bean is created, using reflection, the container says this class has a method that matches to a join point that's associated with a point cut that has an associated advice. Proxy it, and the proxy will be responsible for executing that advice either before or after delegation to the real target object. Clients are unaware that the Spring container has returned a proxy. So, aspects. You need an aspect annotation. It must be Spring managed. We then have a join point. It is the expression you see here. This is saying the join point to the application is execution of the method work that takes 0 to many arguments that can be any class in any package. Then we have a point cut. The point cut is basically a method, but it's really a label. The label here is log with the parentheses. Now we've added an advice, the at before annotation. You can see here it's associating the advice with the point cut log with the join point. The advice is going to execute, in this case, before delegation down to the proxied object, the target, because it's an at before. What's actually happening is the target bean is inflated by the container. As I've mentioned before, reflection says, you've got a work method. 0 to many arguments. Do I have a join point for that? Yes, I do. It's associated with the point cut log, which is associated with the before advice. A proxy is generated, and that proxy will delegate down to the logic in the aspect before it delegates down to the target bean. Now, we can get hold of some metadata by injecting in a join point instance. The join point instance gives us information about the join point, such as what arguments were provided, It'll also get what was the signature of the method that you were trying to get at. So we frequently use this to log within our advices the metadata from JoinPoint. So now we can see, hey, there was a particular employee clocking in. Since we can get at the arguments, we can log that out. We cannot change the arguments in this type of advice. There are many different advices. The before advice we've seen, it'll execute before delegation to the target. The after advice will delegate after delegation to the target, or if it throws an exception. So you could say this is like the finally equivalent in a try-catch block. The after returning advice called after normal method execution without exception. And the after throwing advice is called after method execution, but it exits with an exception. I do not catch the exception. The exception will still be thrown up the execution stack, but I could change it to be a more generalized exception, and that's what I'm doing here. With the after returning, notice how I have two attributes in that annotation. Because we're returning normally, I can get at the return type. So I'm returning foo here. So I look at my arguments to my method, that is my advice. I see a foo argument. I can get at that. I can't change it, but I can get at that. Because we now have more than one attribute, the default attribute point cut, we now have to use in an explicit format. Whereas you see with the after, there was only one attribute, so to speak, the default being point cut, so I didn't have to say point cut equals. Okay, we have a short lab to do with AOP now. You have instructions for it. Once you've completed the lab, I'll get back with you and we can walk through the solution. So I'll see you on the other side. Welcome to lesson 4, transactions. Here we will use the declarative approach for Spring Transaction Management, understand declarative rollback rules to stop a transaction committing, alter transaction commit application behavior via Spring's annotational support for transactions. One of the most compelling reasons to use Spring is actually its transaction model. It's similar to frameworks such as JDBC, Hibernate, or JPA. There is an API to programmatically start and stop transactions, for example, in the Spring framework, or we can use a declarative approach using configurations, in our case through annotations. The Platform Transaction Manager implementation provides access to transactions to start and stop them. These transaction managers include a JTA Transaction Manager for App Server transactions, Hibernate Transaction Manager, mapped to Hibernate transactions, Data Source Transaction Manager to RDBMS transactions. Spring just delegates to the underlying transaction manager from these sources. It does not change the way any transaction manager acts. We need the source of the transactions, like a data source and a transaction manager. Both get provided for you by Spring Boot when using a data source. Below, we have defined an external database, Derby, in our application properties file of a Spring Boot application. With just this configuration, we will get a JAVAX SQL data source, and Spring Boot has registered an implementation of Platform Transaction Manager, namely a JPA Transaction Manager. finding a single JPA entity manager factory to align single JPA entity managers to a thread of execution within a transaction. Using a transaction manager abstracts away the specifics of any transaction API. Spring Boot is going to take care of it for you. So the scope of a transaction we need to consider. So a transaction could span many beans in your Spring application as it transgresses from one bean to the other through method invocation. A transaction propagates from bean to bean using the resources from each of those beans, the methods. We have transaction attributes that can control the transactional state and determine the context that an invocation runs in. These transaction attributes include propagation, isolation, timeout, and whether the transaction is read-only. As appropriate, the container starts a transaction or propagates an existing transaction from one bean invocation to another under the control of our attributes. So, transaction demarcation. In your code, you can definitely interact directly with the transaction manager. They all implement the same methods: get transaction, commit, rollback. But declarative transaction managers allow Spring configuration to control the scope of a transaction. The smallest scope is usually a single method within a bean. Programmatic does allow a sub-method control of a transaction, whereby a single statement could be wrapped in a transaction. Using declarative transaction support at the method level has the least impact on the code and is consistent with having a non-evasive, lightweight container controlling our transactions rather than the code. Believe it or not, this is made possible by proxying your beans, much as we saw with AOP. This is hidden from you, but behind the scenes, there is proxying going on of beans with respect to them starting, committing, and rollbacking a transaction. We need to look at transaction propagation. This is an attribute we will associate with our transaction annotation. They support the following propagation attributes. Mandatory. We'll use an existing transaction if present, otherwise it will throw an exception. Nested. If a transaction exists, it will mark a save point to roll back to, otherwise it will act as we will see like required, which is the default. Never must execute outside any transaction. If a transaction is present, it will throw an exception. Not supported, suspends an existing transaction and starts it again after execution completes. Required, the default will use an existing transaction if one exists, otherwise it will create a transaction. Requires new, will suspend an existing transaction if one exists, will always run in its own transaction. And supports, will use an existing transaction, otherwise it will run without a transaction. These can be specified at bean or method level. As I've mentioned, required is the default, so you wouldn't have to do anything. These attributes are applied to the @transactional annotation that Spring provides. And you can see here that the @transactional annotation has our propagation attribute. What happens here is this method is marked with @transactional, so this bean that this method in will be proxied using Spring's transactional advisor, much as we saw with AOP. What does the proxy do? It starts a transaction before delegating to the target bean with this method in it, and then it will decide whether to roll back or commit once this method returns. A simple update is shown below. We retrieve the employee, by its ID, we set the department, and we leave the method. The transaction is method scoped. It will commit at the end of the method. That commit will be in the wrapped proxy that this bean is living in the IOC container. So we're now going to look at declarative rollback rules. By default, Spring marks a transaction for rollback if it's an unchecked exception, i.e. a runtime exception. If that is thrown from the code executing in the transaction, it will mark the transaction for rollback. It's the recommended way to use runtime exceptions. The container will catch the unhandled exception as it bubbles up through the call stack and will mark it for rollback. For checked exceptions, this is not the default. If they are thrown in the scope of the transaction, Spring will not automatically mark the transaction for rollback. We can refine these rules of when an exception will or will not cause a rollback. The transactional annotation has the following elements that we can use. No rollback for. This will take classes in a list that will no longer trigger a rollback. Obviously, this is used for runtime exceptions. We have the no rollback for class name. This will take an array of class names that will not trigger a rollback. On the other side, for checked exceptions, we have the rollback for, which will take class names that we should trigger a rollback. And we have rollback for class name, which will trigger a rollback using the class names as a means to control which checked exceptions will cause the rollback. Let's try and use this. In our service object below, we have one method. There's an insert and then an update, and then we throw an exception by the look of it by blowing up. Well, let's see what exception we throw. This is the repository that we are going to interact with. We were delegating it down to it, as you see here, for each of the methods. We have a modifying query, which is being marked as transactional. It's using the default, which is required. We have our blowup method put into the repository as a default method that will throw a runtime exception. Remember, runtime exceptions result in transactions being marked for rollback. So if we run that method, we will interact with the repository 3 times: for the save, for the update, for changing a department, and then for the blowup. Based off our configuration, if we go back to our method here, the method has been marked as required. So if a transaction exists, it will use one. Otherwise, it will create one itself to run the entire method in one transaction. So the save, change department, blowup, all in one transaction. Because of the blowup, the runtime exception is thrown. The entire transaction is marked for rollback. There will not be a save. There will not be an update. The state of the database will not have changed. Now, if we change the change department method to have a different propagation requires new, it means the interaction with the database with respect to change department will happen in its own transaction, suspending an existing one if it exists, executing its own transaction, committing or rolling it back, and then resurrecting the original transaction. So now this runs in its own. So our model looks like this. Save transaction 1, change department transaction 2, blow up transaction 1. The result of running the method is that transaction 1 starts, it gets suspended, transaction 2 starts, it gets committed, transaction 1 resumes, we throw the runtime exception, we roll back transaction 1. What happened in transaction 1? The save. What didn't happen in transaction 1? The change department. The department on the database has been changed because it was interacting with the database through its own transaction. The save has been rolled back, so we can control the scopes of our transaction with these propagation attributes. We have a pretty small lab view now to play around with this propagation attribute of the @transactional annotation. Follow your lab instructions. I'll then walk through the solution with you once you've completed the lab. See you on the other side.